Welcome to this new one-shot video in one-shot series. In this video, we are going to systematically start with weightage of sequencing series in JEE Mains. Then we are going to go into the syllabus comparison from 23 to 25. Then we are going to systematically dive into mind maps and see what exactly the syllabus of this chapter entails. And ultimately, we are going to go into 15 problem types. So I have made your life super simple by dividing all previous year questions into 15 problem types. Understanding the methods to solve those 15 types will empower you as a student to take on any question in JEE Mains 2025. Now, before starting this video, there is a small disclaimer. This video is only useful for those students who have already revised the chapter to a certain extent, wherein they know the basic formula, basic concept. So without any further delay, let us start with it. So if I look into the syllabus comparison, you can see that in 2023 and 2024 there are two major syllabus changes that happened. You can see that sum of series of n terms and a special series sum of n terms, sum of series involving n square, those things were removed from the syllabus. So you can see that there are these portions that they have removed from the syllabus. So this were removed from the syllabus, AGP was removed from the syllabus, and these were the major changes. So when I made my one-shot video in 2024, I kept these points into mind. But what NTA did was basically, despite removing these areas, there were questions based on these areas. So what I have done is, I have now this year's one-shot video, I have included questions based on AGP. I have included questions based on logarithmic series. And I have also included questions based on method of difference, because all of these questions were included. So you should be aware of techniques to handle all of these questions, because this can again happen that they have removed it from the syllabus despite the question can be asked. Now we can see that if I start this topic from mind map point of view, the chapter starts with arithmetic progression, where we start with the idea of nth terms, sum of n terms, property and means. And then we go into GP and do the similar kind of analysis. Then we go into HP and do the similar kind of analysis. We also go into the details of relationship between means, that is G square is equal to AH when we have only two terms. And then there is this idea of AM is greater than equal to GM is greater than equal to HM, that can be used to solve inequality based questions. There is a last but very important part of the chapter, that is nothing but sum of series. In the sum of series, we have the first most important series is AGP, then there are summation based questions, and ultimately questions based on method of difference. Now you can see that the red part that I have seen is technically in the syllabus of JEE Mains, and the blue part including red part is also in the syllabus of JEE Advanced. But it is safer, as I have already told you, there had been questions on series last year, so it is safer to prepare this topic considering the holistic syllabus from JEE Advanced point of view. So now let us start with the first part of the syllabus, that is arithmetic progressions. Now by definition, arithmetic progressions are those progressions where terms increase or decrease by a fixed number. That is, the common difference is always constant. Now if you look into this part, you can see that these are the basic results that are available to us. If I go into that, the first and the foremost idea is the idea of general term, where we have a formula that nth term is nothing but a plus n minus 1 into t. The sum of n terms, now we can find using this formula n by 2 twice of a plus n minus 1 into t. I don't think that in this video I need to tell you what is a and d. Now if I want to write this formula, another way I can write this is n by 2 into a plus l, where l being the last term and a being the first term. Also, if I want to find Tn using this sum of n terms, that I can use this formula Sn minus 1. If I take the sum of n terms and remove n minus 1 term from it, we are going to get the nth term. And lastly, we have one more formula that is given here, wherein this Tn plus 1 by 2 is nothing but, in this Tn formula, just replace n by n plus 1 by 2. Okay, very used. Now from JEE point of view, this formula has been used very less. So even if you do not remember this last one, it is totally fine. But first four you should always know. Now this is our first type of problem, that those problems that are based on nth term of P. Now in order to make it much more interesting for you, what I have done, I have taken those problems that came into 2023 as my first preference, and then 2022 and then 2025 I want to cover some more ideas. So by just watching this video, we will be able to cover all the previous year questions that have been asked in the last 2-3 years. Now let us look into the first question based on this problem type. So in this question, and in fact any question of AP, there are two important factors to be determined. And those two important factors are the first term and the common difference. So now this series talks about two different types of arithmetic progressions, one in terms of A, another in terms of B. And they have given the value of A1, that is the first term, already as 2. B they have not provided, but that we can find because we have given the value of A10. So the value of A10 in the question is given as nothing but 3. Now using these two informations, let us find the value of D, because once you have got A and D, then we can find the value of A4. So A10 can be written as nothing but A1 plus 9D, D1. So this is nothing but 3, this is nothing but 2, this is nothing but 9. So from here, if you solve, the value of D1 comes out to be 1 by 9. Now since you have both the values, we can find A4, that is nothing but A1 plus 3D1. Since your A1 is given as nothing but 2 and D1 we figured out to be 1 by 9, this becomes 2 plus 1 by 3 or nothing but 7 by 3. So now in this second part, or looking into the second AP, we can find the value of B1, it is given as nothing but 1 by A1 from this relationship. So it becomes nothing but 1 by 2. If I find B10, it is nothing but 1 by A10 by another relationship that is given to us. So that can be written as nothing but 1 by 3. And again, if I apply the formula for B10, it is going to be nothing but B1 plus 9 times D2, or the common difference of the second series. Now if you write this value as 1 by 3 equal to 1 by 2 plus 9 D2, you can subtract, and the value of 9 D2 can be written as 1 by 3 minus 1 by 2, and that comes out to be minus 1 by 6. So a D2 is nothing but minus 1 by 54. Now once you have got the value of D2, we can find the value of B4 as nothing but B1 plus 3 times D2, and B1 was nothing but 1 by 2, and this D2 has come up with nothing but minus 1 by 54. If I simplify this, this becomes 1 by 2 minus 1 by 18. That comes out to be nothing but 9 minus 1 by 18. And if you simplify that, you get the value of B4 as nothing but 8 by 18 or 4 by 9. So now your A4 was nothing but 7 by 3. Your B4 is coming out to be nothing but 4 by 9. So if I want to find A4 into B4, I can easily get them by multiplying them. And it comes out to be 28 by 27. And that, if I look into my options, is nothing but option D. Now let us look into this another question that came in 2022. In this question, they're talking about different arithmetic progressions that can be formed using first term as 100 and the last term as 199. So they have not told us what is the common difference. They have not told us how many terms will be there. These two informations are given. So if I write last term as 199 and let us assume n terms in that arithmetic progression, it can be written as A plus n minus 1 into D. Here n and D both are unknown to us. But now they have given two important conditions for us to figure things out. The most important conditions that they have given is that the common difference is nothing but integer in nature. See, now this is the very important statement, because if I simplify this, this becomes 99 is equal to n minus 1 into D. And now what they're telling is, see, this part D is also an integer. And if you look into this series, the nth term is actually more than the first term. So the series is increasing. So it is not just an integer, it is a positive integer. Also, this part is a positive integer. So now what you can observe from here is, this is multiplication of two integers. And this statement is very significant because this will help us solve the question. So now what all we need to do is, we need to write, or we can express 99 as multiples of two positive integers. And that could be the possible values of n and d. So if I do that, so for that we'll have to first write the prime factorization of 99. That is nothing but 3 square into 11. So what can happen is, we can take 1 here and 99. This could be one of the cases. Another case could be, we can take this as 3 into 33. Another case could be, we can write 9 into 11. Another case we can write 11 into 9. Or we can take one more case and write this as 33 into 3. And another case we can do is we can write this as 99 into 1. So here this value that we are writing is nothing but the value of n minus 1. And this value that we are writing is the value of d. So 1 into 99 is different than 99 into 1 because the value of n minus 1 and d will get reversed. Now once you have done that, they have given one more restriction in the question. The restriction is we have to find the sum of common difference, this is the question part, such that the total number of terms are at least 3 and at most 33. So we cannot have terms less than 33 and more than less than 3 and more than 33. If I take my first case that I made here, so in this first case you can observe that if I find the value of n, it comes out to be, this is n minus 1 is equal to 1, so n will become 2. In the next case it will become 4. In the next case it will become 10. So whatever value we are getting here, we are adding 1 because this is the value of n minus 1. And in the next case it will become 12. In the next one it will become 34, and in the next one it will become 100. So what they are saying is you can only take those values for d in which the least term is 3 or the most term is 33 terms. So we can choose this one, it is fine, this one is fine, this one is fine, this we cannot choose, this we cannot choose, this we cannot choose. So corresponding to that, now if you look into this distribution that has happened or cases, this can be the possible values of d that is there. So if I take these three possible values of d and add them up, it is 33 plus 11 plus 9, and this comes out to be 53. Now let us look into another question. This is a little bit more interesting question because it talks about groups of elements and then something regarding the sum of those groups of elements. So if I take an example, what the question is saying is, what they are saying is, if I take, let us say, this set, what is the sum of elements in this set? So what they are asking is 6 plus 9 plus 12. What will be the value of this? Now this you can do in multiple ways. What I am doing is, and what I am thinking of doing is, so instead of doing this, let us add the value of the first set into this and then subtract the value of the sum of the first set. So in this we will be able to get the sum of all the elements in the second set. And now this becomes easy also because this part is nothing but a sum of arithmetic progression, and the second part is also a sum of arithmetic progression. So this becomes the core thinking process behind solving this question. So now taking that into consideration, if I want to apply the same strategy, what I will have to do is, first I will have to find the sum till 11th set and then find the sum till 10th set and then subtract them. If I do this, I will be able to get my answer. Now for doing this, we know that if I write all the elements in the sequence in the respective of the sets, it is in arithmetic progression, like 3, 6, 9, 12, 15, 18, 21, 24, 27. This is an arithmetic progression. So if I can just find how many elements till will be there till 11th set, it will be very easy to apply the formula of sum of AP and get to the answer. So now in order to get this, the other challenge is we need to find number of total elements till set 11 and set 10. Set 10 will be important for finding the second term and 11 will be important for finding the first term. Now how to do that? Now if you closely observe, the number of elements in the first set is nothing but 1, in the second set is nothing but 3, in the third set is nothing but 5. So you can see that the number of elements in every set is nothing but an odd number, so it is also in AP. So if I want to find the total number of elements in the till the nth set, it would be nothing but sum of this AP. Again, so what I'm saying is, if I want to find that sum total number of elements till this set, I will have to add 1 plus 3. If I have to go till third set, I will have to add 1 plus 3 plus 5. And if I have to go till 11, I will have to add all the elements or the number of elements in each of this set till 11. And that would be nothing in AP because 1 plus 3 plus 5, you can observe it is an arithmetic progression. So if I want to find an 11, it is nothing but sum of this 1 plus 3 plus 5 till the 11th set. So this can be written as 11 by 2 or twice of A plus n minus 1, that is 11 minus 1 into D, that is nothing but 2. And if you simplify this, becomes 11 square or 120. Similarly, if you want to find n10, it will be 10 by 2 twice of A plus 10 minus 1 into D, that is nothing but 10 square or 100. Now this is the result also. If you find the sum of the odd terms, consecutive odd terms till n, it is always equal to n square for n terms. So that result, if you remember, you can directly use it and then the solution will become even smaller. So if I figured this out, now S11 becomes a simple job to find. In order to find S11 or sum of all the sets till 11, I can do it by using 121 by 2. Twice of A. Now for this series, you can see that A will become 3 and n minus 1. So that is 121 minus 1 into D. Then in this situation would become 3 because now we are considering this series 3, 6, 9, 12. So common difference is 3 here. And similarly, we can find S10 by writing 100 by 2 into twice of A plus 100 minus 1 into 3. Once you have got this calculation, you can do this calculation. You can take this S11, subtract from S10, these two values, and the answer comes out to be 699. Now let us look into this very simple question that came in 2024. Question has two parts. In the first part, it talks about a progression that if you observe, if I subtract the consecutive terms, you can see that the value of D comes out to be constant as nothing but minus 3 by 4. So we can conclude that this progression that is given to us is nothing but an arithmetic progression. If I move to the second part, they want us to tell me the 20th term but from the end. So I will have to reverse the progression. So first term will become minus 129 1 by 4, so on and so forth, and we want to find the 20th term. So in the step 3, what we are going to do is we are going to apply the formula of T20. That is nothing but A, that in this case becomes 129 1 by 4 plus n minus 1, that will become 19, and common difference now will become 3 by 4 because we have reversed the order of this progression. So what is decreasing from the front will become increasing from the end. If I simplify this, this comes out to be minus 115. That matches option A. Now this next 2024 question talks about the value of 6th term. So if I start from step 1, they have given us the value of the 6th term. That can be written as A minus 5D, and this is nothing but 2. In the second part, what they are asking, the product of these three terms is greatest. So let us write the function. So if I multiply them, it will be A into A plus 3D into A plus 4D. They want us to maximize this function. So let us write this, simplify and write this function as a function of D. So if I substitute the value of A from the first part, it will be nothing but 2 plus 5D. If I do it in the second term, it will be 2 plus 8D, and the last one, it is 2 plus 9D. Once we have done this, now if you can see that clearly it has become a function of D. We want to maximize it. So in the third step, we can differentiate it. So if you differentiate it, what we are going to get is, there are 3 terms in multiplication. Differentiation of first term will become 5. With respect to D, we are differentiating. The rest 2 terms I can keep as 2 plus 8D and 2 plus 9D. Then we'll keep the first one constant as 2 plus 5D. Differentiate the next one. And if I do so, it becomes 8 into 2 plus 9D. And then I can do the same process by keeping the first 2 same and differentiate the last one. You can see that this becomes 9. Now since we want to maximize this function, the idea would be to put this equal to 0 and apply first derivative test to get the answer. So in the next part, let us simplify it. So if I simplify, what am I getting? 5 into, this will become nothing but 4 plus 17D plus 72D square. The next part will become nothing but 8 times 4 plus 14D plus 45D square, and the last one will become nothing but 9 times 4 plus 13D plus 40D square. This is equal to 0. So you can see that now after this, the fourth step would be to draw wavy curve. And from here get the value of local minima, because what they want is the greatest local maxima, and from there we'll get the value of D. You can do this last step and get to the final answer. The answer should be equal to 8 by 5. The type 2 question is the questions which are based on sum of arithmetic progression. Now let us see a question that was asked in 2023 JEE Mains. In this question, they are talking about S1, S2, S3, S10 be respectively the sum of 12 terms of 10 APs. So they are talking about 10 different APs whose sum of 12 terms are given. Now, whose first terms are already given to us is 1 to 10. The common difference is also given to us. What they're asking is what will be the sum of those sum of 10 terms. Okay. So if I write it down, it is S1 plus S2 up till S10. This is what this notation means. And now if I want to write the value of S1, it would be nothing but n by 2 twice of A plus n minus 1 into D, that is also 1. If I want to write the second term, it will be again 12 by 2 twice of 1, in place of 1 now this will be 2 plus n minus 1 into D, that in this case would be 3, and we can keep on writing like this. If we keep on doing this time and time again, what you can observe here is, in this specific case, it is happening in such a manner that I can take a lot of terms common, like this 12 by 2 or 6 can be taken as common. If I do so, what will be left inside? In these two terms also we can take 2 common, and what will be left is this 1 plus 2, the sum of all the A's that are there up till 10, plus n minus 1 by 2. This you can also, not this one, this term you can also observe will come as 11. Let us also take this common. And if I take this common, what I can observe is I can again get the sum of all the D's that are there up till 90. Now, if I do this calculation, what I get as answer is 7260. Okay. And here also, when you are doing calculation, you can observe here you can apply the sum of n terms of AP. Here also you can apply sum of n terms of AP to get the final answer. Now let us look into this next question. This next question came in JEE 2023. In this question, again, is based on an earlier question that also came in JEE Advanced. So in this question, we are going to see what is the basic core concept behind this question. So in this question, if you observe the one term, that is the first term, it is root of A10 plus root of A11. Now, once you have this, you can rationalize it. So if I rationalize it, it becomes root of A11 minus root of A10 by root of A11 minus root of A10. Now, once I do this, what I will get in the numerator is nothing but root of A11 minus root of A10. While in the denominator, what we have got is A11 minus A10. Now, root of A11 minus root of A10 can be kept as standard, and we can write A11 minus A10 in the denominator as nothing but T. Now, once you have done that, you can use the similar format for all the terms. So if I try and complete this series in this new format, it will look something like this. The first term will be written as A root 11 minus A root 10. The next term would be A root 12 minus A root 11. It will go up till last term, that is A root 18 minus root of A 17. And then we have 1 by T outside. So once you have done this, we have come to this point, and now you can see that alternate terms are getting cancelled out. A11 will get cancelled out. Okay. And you can see that if I do this, all the terms will get cancelled out except these two terms, that is root of 18 and root of 18. Now, once we have this, we can simplify this and write it down as root of A18 minus root of A10 by root of by nothing but T. So once I write it down, what I can do is I can find the value of A18, substitute and get the answer. Because we have also been given the condition that A5 is nothing but equal to A7, two times A7, and A11 is equal to 18. If I use these two conditions, I will be able to get the value of A, D and all the things, and will be able to get the answer. Let us do that. So if I write my condition, A5 is nothing but A plus 40 and 2 times A7 is nothing but 2 times A7 plus 2 times 60. And if I simplify this, it is A plus 4D is equal to 2A plus 12D, or A plus 8D will be equal to 0. This is the first condition that we have got. If I move further and write another condition from the another term, it is given A plus 10D would be equal to 18. So if I subtract this and the earlier condition, I should get the value of D. And if I do that, my 2D comes out to be 18 and our D comes out to be 9. Again, what you can do is using this, if I substitute in the first one, it becomes A minus A plus A into 9 equal to 0, or A is equal to minus 72. Now since you have got the value of A and D, here you can find the value of A18 and you can also find the value of A10. Solve and get the answer. Let us see this new question. Now in this question in JEE 2021, they have used a similar idea of difference of two terms. Now if I take the nth term that is given to us, that is nothing but 1 upon an into an plus 1. We can write the same term as an plus 1 minus an by an plus 1 into n. The benefit of writing this, because see, since the series that they have given is in arithmetic progression, so the sum or the difference of two consecutive terms is going to be d. So what I can do is I can multiply them by an plus 1 minus an, and this denominator term will become equal to d. So this we can write as d and take it out. It becomes an plus 1 minus an by an into an plus 1. And now if I simplify this, this becomes 1 by d times 1 upon an minus 1 upon an plus 1. If I write the whole series using this concept, this is how this series looks like. It will start with the first term. So 1 by d we can take out. The first term becomes 1 by a1 minus 1 by a2. The next term becomes 1 by a2 minus 1 by a3. And it will go till 1 by a20 minus 1 by a21. Till here we can write the whole series. See, once we have written this series, what we will observe here in this question is this alternative terms are getting cancelled out. So all of this will get cancelled out, and towards the end what we will left is 1 by d into 1 by a1 minus 1 by a21. And you should smile after looking into this, because now if I take LCM again, it becomes a21 minus a1 by a1 into a21, and they have given the value of this expression as 4 by 9. We can equate this to 4 by 9. Okay. So after doing this, the next step is quite simple. In our next step, we can observe that the numerator will be nothing but 20d, because a21 is nothing but a plus 20d, and divide by this a1 and a21. Now this is given as 4 by 9. So if I simplify, you get the value of a1 into a21 as nothing but 45. The derivation is the sum of terms from a1 to a21 is equal to 189. So let us also write that. So if I start from a1 to a21, it is 189. So if I apply my formula on the sum of n terms, it is n by 2, twice of a1, and more importantly, we can write this as a first term plus last term. So a1 plus a20 is equal to 189. So what I will get is nothing but 7 here, and this becomes 63, and now if I divide by 7, it becomes 9. So a1 plus a21 is nothing but 18. Now if the product of them is equal to 45, sum is equal to 18, so you can also guess, but if you are finding it difficult to guess, you can substitute the value of a1. So a1 plus 45 by a1 is equal to 18. If you simplify this, this becomes a quadratic. So a1 square minus 18a1 plus 45 equal to 0. And if you solve this quadratic, you get two values of a, 3 and 15. We can consider any value. It will not make much of a difference. Now, after getting this, the next part is to find the value of, see, first term is known now. Let us say that it is 3 in the first case. If I consider A21, so this will become nothing but 15. So A1 plus 20 times D will be equal to 50. So 20 times D becomes 12 since A1 was 3. So D becomes nothing but 3 by 5. This is the value of D that we have got. If you can go into this very simple calculation. Once you have got these values, now your life becomes very easy, because now you know the value of A, you know the value of D, you can find A6 and A16, multiply them and get the answer. So if you do that, your A6 would be nothing but A1 plus 5D. So this 3 plus 5 into 3 by 5 comes out to be 6. And if you find your A16, it is A1 plus 15D, comes out to be 3 plus 15 into 3 by 5. And that is nothing but 12. So if I multiply A6 and A16, the answer is nothing but 72. You can go back to your options and check the B option comes out to be correct. If I look into this 2024 question says that Sn be the sum of the first n terms of arithmetic progression. S10 is given as 390, the ratio of the 10th and the 5th term. So let us write things down. So what they have given is nothing but the value of S10. So if I apply the formula n by 2 twice of A plus n minus 1 into D, so that would become 9 into D. This is given as nothing but 390. So this is my first equation. In the second part, they have given me the ratio of the 10th and 5th term. So 10th term will become A plus 9D and 5th term will become A plus 4D. The ratio of same is given as 15 by 7. These two things are given to us. So once these things are clear, now in the next part what they are saying is find the difference between S15 and S5. So fundamentally what they want us to find is, in the third part, S15 minus S5. So S15 plus minus S5 would be nothing but n by 2. So that will become 15 by 2 into twice of A plus 14D minus 5 by 2 into twice of A plus 4D. If I simplify this, 5 by 2 can be taken as common. So what is left is nothing but, this will become 6A 14 into 3 times D minus twice of A minus 4D. You can see that in order to get this value, we will require the value of A and D. So even if I simplify, what will happen? 6A minus 2A will become 4A. 14 into 3 is nothing but 42, and 42 if you subtract 4 will become 38. You can check my calculation though. So again you will require the value of A and D to get the answer, and for getting the value of A and D we have been given two conditions to start with. So in the fourth part, let us try and solve this out. So from the first one, what I can write is, I can write the value of twice of A plus 9D. You can take everything else on the next side. So this will become nothing but 39 into 2. So first equation we have got is 2A plus 9D. 39, 40 into 2 is 80. So this will become 78. This is the first equation. Another one we can get by cross multiplying the things in the second part. And if I do it so, what am I getting is nothing but 7A plus 9 into 7 is 63D. On the right hand side it will be 15A plus 60D. We can easily simplify it down. So if I take a D on the left hand side, this becomes 3D, and if I take 7A on the right hand side, it becomes 8A. So we have got a relationship between A and D. Correspondingly, you also have a relationship between A and D in the first part. So in the sixth step, we are going to solve and figure out the value of A and D. We'll substitute these values in the value of S15 minus S5 that we figured out earlier and get the final answer. The answer to this question comes out to be option C. Now this 2024 question is exactly similar question. Again they are asking us the similar kind of value, S15 minus S5. But instead of giving us two conditions. Now the two conditions given in different manner. S20 and S10 has been given. So again we will figure out the value of A, we will figure out the value of D, put in the expression of S15 minus S5 and get the final answer. Now if I look into this 2024 question, question talks about a mountain kind of a structure where in every row you can see that one element increases. So if I go till kth row, you can see that there will be k elements in the kth row. So kth row, you can see from here, are going to have k elements. This is what is given in the question. This is not something that I am telling you. Once you have read this carefully, now what they are saying is, if k be the row in which 5, 3, 1, 0 lies, then what is the value of k? Now you can see that what is happening is, since it starts from 1, you can see that whatever be the element, like 5, 3, 1, 0, if this is the element, this is also the number in which it will arrive in the arithmetic progression 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because the common difference is equal to 1 and A is also equal to 1. So if you could observe that, what you will understand is, if I start this mountain 1, 2 and like this, and if there is a k minus 1 row here, the total number of terms that might have arrived till here would be nothing but sum of 1, 2, 3 till k minus 1, because this is the number of term in every row. So the answer will become k minus 1 into k by 2, sum of n natural numbers formula we have applied. Now what we are saying is, this 5, 3, 1, 0 lies in the kth row. So here kth row will come. So till here if I want to find the sum of the numbers, it is going to be k into k plus 1 by 2. Once I figured that out, interesting thing would be that this number of term 5310 will lie between these two numbers. So let us make a simple inequality. So what we can say is, k into k minus 1 by 2 should be smaller than 5310 and k into k plus 1 by 2 should be greater than this. You can see that this lies between these two number of terms. If you simplify this, what is going to happen? In the third part, we can just cross multiply. This will become 02610 into k plus 1. So now you can see that you are getting two parts of the inequality, one from here, that is k square minus k minus 10620 is smaller than 0, and another one from here, that is k square plus k minus 10620 should be greater than 0. If you find the common solution, you will get the answer of k as nothing but 103. Now similar kind of question is again asked in 2024. Question says that you start from 2, then 5 will come, then 8 will come. So important thing to notice in this sequence is, the first term is nothing but equal to 2 and the common difference is nothing but equal to 3. Now they have written in a cascading mountain form of way. Now what they want us to find is the sum of terms in the 10th row. See, when we want to find sum of terms, there are two things that we need to know. What is the first term? Then what is the common difference? Now see, common difference is not going to change. It is going to remain 3 only. So this second part we know. If I know first term, common difference and number of terms, I would be able to apply the formula and get the answer. So it is as simple as that. Now in order to get the total number of terms, you can see that every sequence, every row has exactly the same number of terms as the number of the row. So if it is a fourth row, there are 4 terms, the third row 3 terms. So if I am talking about 10th row, it is going to have 10 terms. So this is also figured out, there is no issue with this. Only thing now I don't know is nothing but the sum of the value of the first term. Now you can see that what is happening is, if I could figure out the number of the term that this first term would be corresponding to this arithmetic progression given to me, I can easily figure out the first term. That would mean if I just figure out how many terms are there till the 9th row. So till 9th row, you can see that it will be 1, 2, and like this till the 9th row. If you go, 9th row will have 9 terms. So if you figure out the total sum, it comes out to be nothing but n into n plus 1 by 2, this comes out to be 45. You can see that the 46th term that is going to come is going to become the first term. If you want to find this first term corresponding to our series, let us call this as A dash. It is going to be nothing but A, that is 2, plus n minus 1, that will be 46th term minus 1, because 45 terms are before that. And into D, that will become nothing but 3. So we have got the value of A, 2 plus 45 into 3. 45 into 3, and that would come out to be nothing but 90 plus 45, 135. So this becomes 137. You can check my calculation. In the third part, we are going to apply another formula because we have got everything. So it will become n by 2. So 10 by 2 twice of A dash, that is 137, plus n minus 1, that would be 10 minus 1, into D, that is nothing but 3. You simplify, the answer comes out to be 1505. Please check my calculation. If I look into this 2024 question talks about two different ideas. One is the idea of small a1, small a2, small a3. We are saying that this is an arithmetic progression of positive terms. So all the terms are positive. Second thing, they are talking about a capital K. Capital AK, that would be a1 square minus a2 square, a3 square minus a4 square. So what you should observe here in the first part is, when we are writing this AK, I can group first two terms, then next two terms, so on and so forth. So it will become a square minus b square, can be written as a1 minus a2 and a1 plus a2. Now I can keep on writing this. Then the next one will become a3 minus a4 into a3 plus a4. And I can keep on writing it till the last term. That will become a2k minus 1 into a2k. Plus a2k plus 1 plus a2k. If you do it in this manner, you can see that what happens as a result is this a1 minus a2. Since a1, a2, a3 are in arithmetic progression, if I take the common difference as d, this will become minus d and this will be there in all the terms, so I can take it out. What I am getting is a1 plus a2 plus a3 plus a4 till a2k. And now if I do this, you can very clearly observe that it is nothing but sum of 2k terms. So if I want to write it down also, this can be written as 2k n by 2 twice of a 1 plus 2k minus 1 into d. So you can see that we have figured out the value of ak in the first part. Now for finding the value of a and d, because everything will depend upon a and d, they have given us the value of a capital A, and in the second part they have given us the value of a3. So in place of k, if I put 3, this is going to become minus 3d twice of a1 plus, if I put here 3, it will become 6 minus this will become 5d. Now this value is given to us in the question as minus 153. And the second part, that is a5, if I do, you can see that again, if I put the value as 5, this will become nothing but minus 5d into twice of a1 plus 9d. This is given as nothing but minus 435. You have got two equations, two unknowns. Solving this, in the fourth part, we can figure out the value of a and d. Once you have figured out the value of a and d, then whatever they are asking, those questions can be very easily answered. If I look at this 2024 question talks about arithmetic progression in which first term, second term, third term is given. So just by looking into this arithmetic progression, you can tell the value of a is 3 and the value of d would be nothing but 4. Now what they have given is an expression, that is sk. If I figure out the value of sk, it would be n by 2 twice of a, that is nothing but 3, plus n minus 1, that is k minus 1 into d, that is nothing but 4. If you figure out the value of k, it comes out to be 3 plus 2k minus 2, or k into 2k plus 1. If I figure this out, this becomes 2k square plus k. This is the value of s of k. Now what they are saying is, if you take this value and put a summation over it, the second part, let us put a summation over it. So we are doing summation from k is equal to 1 to n, and now over s of k, and that will become 2 times summation of k is equal to 1 to n. k square plus summation of k is equal to 1 to n k. And if I do so, this becomes 2 times n into n plus 1 to n plus 1 by 6 plus n into n plus 1 by 2. If you simplify this, you can see that this 2 will get cancelled out, this will become 3. And what we have got is an expression out of which n into n plus 1 can be taken as common. This will become 2n plus 1 by 3 plus 1 by 2. In the third part, what they are saying, if I go back to the question, they are multiplying it with 6 times n into n plus 1. So 6 times n into n plus 1, summation of k is equal to 1 to n s of k. If you write this value, you can see that n into n plus 1 and will get cancelled out. 6 will go inside and this will become 2 times 2n plus 1 plus 3. So answer becomes nothing but 4n plus 5. Now in the fourth part, what they are saying is this value 4n plus 5 lies between 40 and 45. So 4n will lie between nothing but 35 and 40 in 37. So if I divide by 4, let us see what is the value of n that we are getting. So 35 by 4 and 37 by 4. So you can see that for 4 into 9 is 36. This is 8 point something. And you can see that this would be 9 point something. So only possible integral value is nothing but 9. The value of n comes out to be 9. Now next types of questions are those that are based on properties of arithmetic progression. Now let us quickly go back to the properties first and then see what kind of questions JEE has asked in the recent exams. So if I go back to the properties, the first is basically use these properties of assuming terms. This is the first category of properties. Use only them when the question talks or gives some condition in terms of sum of the terms. Otherwise, this kind of properties will not help you much. And it is not that if you use it will not make it lengthy, it will make much complicated than it should be. So it is very important you keep in point that only use these conditions when sum of the terms is given in the question. Now, the second property says that if you have to assume 3 terms, then you can assume the terms as a minus d, a and a plus d. So you are starting from a minus d and you are considering the common difference as d. But if you have to assume even number of terms, the concept says that assume those terms as a minus 3d, a minus d, a plus d and a plus 3d. You can see that if you have to add these terms, the d parts will get cancelled out and directly will get the value of a. And that is the utility of using this property. And of course, if no sum condition is given, then there is no point using this because it is only going to introduce some more minus signs into the question and make your calculations much more complicated. Another thing to note about this even number of terms is here the common difference is nothing but 2d. So this small things sometimes make difference. Next is operations with constant. Now this is very interesting. Like if you have, I will take an example to explain 1, 2, 3, 4. This is your arithmetic progression. So what we are saying is if you add 5 to all the terms, so we are adding 5 first. So you can see that what happens is this becomes 6, 7, 8 and 9. Still this is in AP. If you add a constant term to an AP, it still remains in AP. You can see what happened is your first term has changed. Your first term has become 1 plus 5. So whatever constant we added got added to the first term, but your common difference remains same. If you subtract 5, again it becomes minus 4, minus 3, minus 2, minus 1. So again you can see it is still in AP. But the first term has been reduced by 5, wherein the common difference remains same. And if you move further and if you multiply by 5, the same AP becomes 5, 10, 15, 20. Still in AP, but now the first term has become 5 times because the constant was 5. And the common difference has also become, you can see that has also become 5 times. So now both of them are getting multiplied to that constant. And if I divide by 5, let us see what happens. It becomes 1 by 5, 2 by 5, 3 by 5 and 4 by 5 is still in AP. But the first term has been reduced, become 1/5 of its original value, and same goes for its common difference. So it is very simple to remember. If you forget, take this very simple example, and from there you can formulate the theory and move ahead. So the next set of properties that we are looking into is the properties that are based on means. And now, interestingly, when we say mean, what does that mean exactly? So if I'm taking two terms, let us see first two terms. So if I'm taking, let us say 1 and 3, the mean would mean nothing but the average. So 1 plus 3 divided by 2. So what we are saying first is, if you have two numbers A and B, then the mean would be nothing but A plus B by 2. And now this way is fine. So if I take three numbers like A, B, C, now what does mean would mean? Mean would mean A plus B plus C by 3. If you have more than one numbers, like more than three numbers, 4, 5, 6, 7, n numbers, we have a general formula A1 plus A2 plus A3 till AN divided by. So this is one way of visualizing the whole idea. Another way is something known as inserting means. What does that mean? So that means basically if I am taking three numbers like 1, 2, 3, what would that mean? That would also mean that 2 is a mean between 1 and 3. That is another way to look into it. So the statement means that 1, 2, 3 will be an arithmetic progression. So if you look into this, 2 now can be written as nothing but 1 plus 3 by 2, or 2 into 2 will be equal to 1 plus 3. In other words, if you have A, B, C, we can write this as twice of B will be equal to A plus C. The reason is that I can get this from very simple property, that B minus A will be equal to C minus B. If you simplify, you get this idea. Okay, so this is one way. This is the first result. I have also explained you what is the concept of mean means for 3 terms, for n terms. Now, if you have to look into this mean concept, there are few properties as well. So this was one idea, this is another idea. And then there is this whole idea of the properties. If you have 1, 2, 3, 4, 5, what you can observe is, if you take mean of 1 and 5, that is 1 plus 5 by 2, it comes out to be 3, that is this number. If I take 2 and 4, still the mean remains same, 2 plus 4 divided by 2, 3. And if I take 2, 3, 4, 2 plus 3 plus 4 divided by 3, because there are 3 numbers, still it remains 3. So this is a very useful thing. We are going to use this. And fourth idea is inserting arithmetic means. So now what they are saying is, let us say we have 1 and 5. And I have to insert two arithmetic means. That means I have to put two numbers here, A1 and A2, in such a manner that A1, A2 and 5 are nothing but in arithmetic progression. So now in order to do that, what we are going to do here is, we are going to find the common difference, because A we already know, D if I know, I will be able to tell all the terms. So what we are doing is 5 is equal to A plus n minus 1 into D. So 4 minus 1 into D. So you can see that from here D comes out to be 4 by 3. Since you have this, using this you can find the value of A1, that is A plus D, or nothing but 1 plus 4 by 3. And if you want to find A2, you can write this as A plus 2D, or 1 plus 2 into 4 by 3. The interesting thing to observe here is, when we write A1, it is A plus D. When we write A2, A plus 2D. If I have to write AN, it will become nothing but A plus ND. So again, just to put things into perspective, AN or A1 or A2 is not the number of terms. It is the number of arithmetic mean inserted between two terms. Okay. Now this question says that, and this question was asked in JEE 2023. It says that A1 is equal to 8. The first term 8 they have given. They've also told us that A2, A3, A until AN, these are in arithmetic progression. The sum of the first 4 terms is 50. The sum of the last 4 terms is 170. The product of the middle two terms is, fine. Product of the middle two terms is, this is what they are saying. So here one thing is implied, there are two middle terms. Okay. So now what does that mean? So if you have like 1, 2, 3 odd number of terms, there is one middle term only. But if you have even number of terms, there are two middle terms. So when they say two middle terms, it is already implied that they are going, the value of number of terms are going to be even only. Otherwise, two middle terms are not possible. Now if I move further, what they are saying is the sum of the first 4 terms is 50. So what I can do is I can write it as A plus D plus A plus 2D plus A plus 3D. So these are first 4 terms. It comes out to be 50. This is one thing, they have information that they have provided. Another thing that they have provided is nothing but the sum of last 4 terms is nothing but 170. It can be written as CL, then L minus D plus L minus 2D, and then L minus 3D. You can see that exactly properties we are not using, but something inspired from the properties we are using. Now, if you add them up, and if you add these two equations, what will happen is d terms will get cancelled out. We will get a plus l. Then from second term also a plus l. Like this, we will get a plus l 4 times, and this will be equal to nothing but, if I add 50, this becomes 220. This is what we have got. Now, once you have got this, this is nothing but 4 times a plus l, and this is nothing but 220. What I can do is I can divide by 4. So if I divide it by 4, it becomes, and once you have got 55, from here we can get the value of L, because A they have already given as 8. So 55 minus 8 will be equal to my L. And if I do that, and it comes out to be nothing but 40. The question says that we have to find the value of D. For finding the value of D, we will use our first relation. So if I use this, this is nothing but 4A plus 6D is equal to 50. A is already given as 8, so this is 4 into 8 plus 6D is equal to 50. You can solve and get the value of D as 3. Once you have done that, you can move ahead. And now in order to find the value of total number of terms, let us go back to this value of L, or the last term, that was 47. If I take that, A plus N minus 1 into D, it will be equal to 47. Now let us put the value of all the things here. A is nothing but 8 and D is nothing but 3, equal to 47. Again, you can solve and get the value of N is nothing but 40. Now, if you have done that, what you will observe that since the value of N is 40, there are two middle terms here. The value of the two middle terms now can be written as nothing but A7 and nothing but A8. We have to find the multiplication of these two. So first will become A plus 60. Another will become nothing but A plus 70. And it is not a difficult thing, because we know the value of A as 8 and D as nothing but 3. So if I put the values, I get my answer. Let us go into the next question. In this question, again, we have to insert n arithmetic means between A and 100. Such the ratio of the first and the last mean is 1:7, and another condition between A and N is given. So let us write it down. So what they are saying is we need to put n arithmetic means. So if I start with A, then the first one is A1, then A2, and AN, and then 100. These are the things. Another information that is given is A1 by AN is nothing but 1/7. And then A plus N is equal to 33. So these three informations are given in the question. Based on this, they want us to solve this question. If I move ahead with this information, this is a very crucial information. If I use this, A1 can be written as A plus D, and AN can be written as A plus ND as discussed earlier. And if I simplify this one, so you can see that this will become nothing but 7 times A plus 7 times D is equal to A plus ND. Or I can move A on the other side. This becomes 6A is equal to N minus 7 into D. And we also know the value of A in terms of N, because in question they have asked the value of N. So I can also substitute this. So D comes out to be 6 times A, that is nothing but 33 minus N divided by N minus 7. These are the values that we are getting. Now once you have got this D, A already we know in terms of N. So we can write the formula for the last one, that is 100. So it is nothing but N plus 2 term. So N plus 2 minus 1 into D we can write. Now in this formula, A we can write this as 33 minus N. And this term, that is, will become N plus 1, and D we already figured out 6 times 33 minus N by N minus 7. See, now there are two ways to move forward. You can take N minus 7 on the other side, make a quadratic, solve it. It takes a lot of time. So an easier way to solve this question would be to satisfy the options. So as you satisfy the options, and if you clearly observe, only odd values of N would get satisfied. And so it would be more sensible to satisfy these two values first. So if you satisfy, you get your answer as C is nothing but N equal to 23. In this next problem type, we are talking about comparing two arithmetic means and figure out what are the terms that are common between those two arithmetic means. Now, this has been a very prominent question in JEE. So let's see what kind of question JEE is asked and how to approach these questions. Now, in order to approach this question, there is this common algorithm. You have to observe between two APs what is the first common term by observation. So we can write the terms and physically observe and what are the terms that are common, which is the first term that is common. Once that is done, now observe the LCM of common difference of the two arithmetic progressions. Let us call that it's capital D. And then the last part is all these common terms will also be in arithmetic progression. So that arithmetic progression will have its first term as capital A and common difference as D. Now let us see how this works out. So this question is given, a very straightforward question. Question says that the number of terms common to the two APs, that we need to figure out. So now you can physically observe here that if I write first term is 3, then 7, then 11, so we are adding 4, it becomes 15, then 19, so on and so forth till 407. If you start with the other, it is 2, then 9, so we are adding 7. So if I add 7 again, and it will become 23. And you can see that if I physically match, the next term in my first series might also be 23, so it is matching. So this is the first step, figuring out the value of capital A. Capital A comes out to be 23 and needs to be done manually by observing. Now let us come on to the second part. In this second part, if I look into the D1, that is the common difference of the first series, that is nothing but 4. And if I look at D2, that is the common difference in the second series, it comes out to be nothing but 7. And LCM of D and D1 and D2 is nothing but 28. So this we have got. In the third step, what we need to do is we can write the arithmetic mean of all the common terms. So that will be something starting with 23 and then you keep adding 28 to get on the other terms. So we can do that and we can get it. Now what they want us to find is nothing but how many terms will be common between both the series. So in order to do that, always take the series with the highest term lesser than the others. So 407 and 709. If you compare the smaller values 407, so take that value 407 and now corresponding to this 407, let us find the value of n. So I am applying the formula of a plus n minus 1 into d. Let us put the value of a and d here. So 407 is fine. My a value comes out to be 23 and my d value comes out to be 28. This will become 384 divided by 28 will be equal to n minus 7. And roughly, if you do that, it works out to be n minus 1 is equal to 13.7. 0.7 is not required. If you can just get the integral value, first part, that is more than enough. You can see that the value is coming out to be 14.7 something. So now I also know that n needs to be an integer and cannot be 14.7. So what we are observing here is if I keep on going with this arithmetic progression, how many terms will be there till I reach 407? So what we are saying is 407 is between the 14th and the 15th term. So before 407, there will be 14 terms that will be arriving. Hence, total number of common terms come out to be 40. So the answer of this question is nothing but 40. Now let us move on to the next question. This is a slight variation of the earlier question. Earlier they were asking how many terms are there. Here they are asking what is the value of the eighth common term. So the first step in this question can be easily done just by observation. You can observe this 11 is the term that is constant. So the value of a comes out to be 11. In order to find the value of d, we need to take LCM of the common difference of first series, that is 4, and the second, that is 5. That comes out to be 20. The third one, if I want to find the 8th common term, it is going to be a plus 7d, capital D. And if I put the values, I get my answer. So 11 plus 7 times 20. So that is nothing but 11 plus 140. So it comes out to be 151. Now let us start with this new question. In this new question, very interesting concept they have introduced of common terms is nothing but 3 arithmetic progressions. Now this is very interesting. So what you need to consider here is you need to work a little bit smart. First, find the common terms between these two series. Why these two? Because they have the highest common difference. The first one is nothing but 4. The second one is nothing but 3. And the fourth one is nothing but 5. So I'm considering the one with the highest common difference. You will understand in a minute why. What is the logic behind that? So once you do that, what happens is here, if I try and write the terms, so here it is also easy to observe the common terms as well, right? So 7 you can easily observe is the first common term. 7 plus, now here this is first thing, and another thing that you can observe is nothing but the common difference. That is going to be nothing, the LCM of 4 and 5, that is 20. So if I take that as 20, the other term, the next term would be nothing but 27, the next term would be nothing but 47, then 67, so on and so forth. Now, since we have taken the common terms of first and third series, now if I consider the common terms of these series, new series, with the second term, I will get the common terms between all the three series. So now, if I consider that, here you can see that these terms, whatever are there, needs to be of the pattern that if I write them, it should be of the form a plus or a2 plus n minus 1 into d2. And what is the specific thing about this? That a2 here is nothing but 2 and d2 here is nothing but 3. So if I subtract 2 from any of these terms, it should be divisible by 3. Only then n minus 1 will become an integer. So that does not get satisfied for first term, second term, but third term is fine, because if I take this as 47 is equal to a2 plus n minus 1 into d2, or 2 plus n minus 1 into 3, and you will get an integral value of n after solving. So this very interesting thing, if you observe in the starting, your life becomes very easy. And now what you have observed is, out of these three series, if I want to write my first step, that is common term between all the three series, that now comes out to be 47. This is the value of my capital A. And if I want to find the value of D, it will be nothing but LCM of this 20 and this 3, that comes out to be 60. So if I want to write my common AP, that would be nothing but 47. And A is equal to 47 we can take, and D is equal to 60 we can take, and write down all the terms. Now interestingly, what they want us to find is not just the AP, they want us to find the sum of common terms, sum of the common terms that are there in this AP. So if I start doing that, the first term is going to be 47. The next, if I add 60, becomes 107. Next, if I add 60, it becomes 167. And you can see that after this, it will cross the minimum term out of this three series, that is 197. So what I need to find is just the sum of these three terms, and I will get my answer. Now this next question works on a very interesting concept. What they're asking is, find the sum of all those terms of this AP which are not divisible by 3. This is very interesting. So we can use the concept of common AP to solve this question by writing our first series as 3, 8, 13 till 373, and another series as 3, 6, 9, so on and so forth. The idea would be, logic would be to find the sum of this first series, first one, find the sum of the common terms that is there, and subtract them to get the answer. Because then the terms which are divisible by 3, and that sum if you find and subtract, will get our answer. So this is the logic that we are trying to follow. So for that, we will have to find our first common term, that comes out to be 3 only. So A is nothing but sorted. Second, we'll find the value of D. Now we can see that here the common difference is 5. Here it is nothing but 3. So my D becomes nothing but 15. And third, if I want to find the total number of terms, it could be find as 373 is equal to 3, that is A, plus n minus 1 into, that is 15. So I subtract, this becomes 370 into n minus 1 into d 15. And if I simplify, my n minus 1 comes out to be 370 by 15. My answer comes out to be 24 point something, and from there the value of it comes out to be 25 point something. You can see that there are in all 25 terms that are common. This we have done earlier also. So now what we are doing is, in order to find S1, that is the sum of the first series, we can apply our concept. So let us first figure out the total number of terms in this series, so 373 minus 3 is equal to n minus 1 into 5. And if I do, this becomes 370 by 5 is equal to n minus 1. And this is nothing but 37 into 2. So n becomes 1 plus 37 into 2. And that would be nothing but 2 into 7 is 14. 1. 74 plus 1. So my n becomes nothing but 75. So there are 75 terms in this first series. So 75 by 2 into twice of a plus 75 minus 1 into d. And d in this case is nothing but 5. So you find this as 1. Now we'll find the sum of this series. That is my S2. And if I do that, there are total 25 terms. So 25 by 2 twice of a plus n, that is 25 minus 1 into d, that comes out to be 15 now. And if you want to find the answer, my answer is nothing but S1 minus S2. You can do the calculation and get to the answer. If I look into this 2024 question talks about common term in the progression 4, 9, 14, 19 up to 25 terms and 3, 6, 9, 12 up to 37 terms. Now we have done a similar question. We can follow the standard process to solve this question. There is nothing new in this. Wherein if I look into this next 2024 question, this talks about, again you have been given to arithmetic progression. They are talking about the sum of the common terms. So let us try this question. Let us find the sum of the common terms. Now for that, first we'll have to go through the same process. First term we'll have to observe, that is common from observation point of view, and that you can clearly observe. It is nothing but 11. So your a of the common AP becomes 11. If you want to find the value of d, it would be nothing but LCM of d1, that is the common difference of first series, and d2, that is nothing but the common difference of second series. So for the first series, d1 is nothing but 4. For the second one, d2, if I figured out, it would be nothing but 3, and LCM of this would become 12. So answer becomes 12. Once you have this, now only thing that we need to know in order to find sum is number of terms in the sequence. For that, we will do the step number 3. For step number 3, now if you look into that, we need to go till 403. And now because this is where, now and then 404, so we will take the lesser of these terms. So if I consider 403 and use this a plus n minus 1 into d, correspondingly you will get the value of d here. So if I do that, a is nothing but 11, n minus 1, d we have already figured out is 12. If I subtract 10, it will be equal to 393, and if I subtract one more, this will become 392. Divide by 12 is equal to n minus 1. Now all I need to do is divide by 12. For that, I can simplify this by dividing it by 2. So this becomes 6. This becomes 1. Then 9 will become 18 and 1. This will become 6. Again I can divide by 2. This becomes 3. If I divide by 2, this will become again 9 and 8, 98. And now I can divide by 3. So if I divide by 3, it will be 3 and 2, so 32 point something. The value of n will become 33 point something. So you can see that there will be 33 terms before 403. So we have figured out that the total number of common terms, the value of the n that we require, actual n that we will require, will be equal to nothing but 33, because this term 403 lies between the 33rd and 34th term. So total number of required terms becomes nothing but 33. So in the fifth part, I can apply the formula and get the answer. The sum of n terms would be equal to n by 2 twice of a. A here is nothing but 11. N minus 1 will become 32. And d we know is nothing but 3. It's nothing but 12. If I simplify this, I should get my answer. So let us simplify and check. So this becomes 33 into, you can see 2 will get cancelled out. It will become 11. This will become 32 into 6. If I simplify, this is 33 and 11. 32 into 6 will become 2. 1, 3, 6, 18. 18 plus 1 is 192. If I simplify this should come out to be 669. You can check my calculation. Next, we are going to look into geometric progression. A geometric progression is defined by a sequence in which the consecutive terms have a common ratio into place. So now let us first see what are the basic results on geometric progression. So there is a result for general term, that is nothing but general term of when GP is equal to A into R raised to the power n minus 1, where A is nothing but the first term and R is nothing but the common ratio. The sum of n terms, if R is equal to 1, becomes NA. If R is not equal to 1, in that case we can write it as A into 1 minus R raised to the power n by 1 minus R. We can also write as A into R raised to the power n minus 1 by R minus 1. And if the number of terms become infinite, then the formula becomes A upon 1 minus R. Important condition for this is nothing but mod of R needs to be smaller than 1. Now let us look into this problem that came into 2023. This problem talks about a GP with positive numbers. This word is very important. And then what they're saying is, if I take the sum of sixth term, that is AR raised to the power 5 plus AR raised to the power 7, it is nothing but 2. If I take product of the third term, that is AR square into AR raised to, and fifth term comes out to be 1 by 9. And what they want us to find is nothing but 6 times AR plus AR cube into AR cube plus AR raised to the power 5. So I have put the values in terms of A and R. Once I do that, now what you can see is we have two equations, and in any equation of GP, like in AP, A and D were important. Here A and R are important. So if you are somehow able to find the first term and the common ratio, then you can get any kind of information regarding a GP. So let us try and figure those two things out. Now here, if you multiply these two terms in the second equation, it becomes A square R raised to the power 6 equal to 1 by 9. And if I simplify, then the value of AR cube can be written as 1 by 3. I am only taking positive sign because they mentioned it in the question. Now, if you have done this from the first equation or the first information they have given us, we can take AR cube as common. This becomes AR cube into AR square plus AR raised to the power 4 is equal to 2. AR cube can be written as 1 by 3, sorry. And this is R square plus R raised to the power 4 equal to 2. We can simplify this. So R raised to the power 4 plus R square minus 6 will be equal to 0. So we are getting two values of R square, minus 3 and R square equal to 2. Obviously, we cannot take the negative value. The second value is nothing but the acceptable value. Now, if I use all of these information to solve question, I have two important ideas. One, AR cube is equal to 1 by 3, R square is equal to 2. I can solve further, but it is not required because I can reduce my question into required form. So if I take A common from both the terms, it becomes A square. And if I also take R from the first term and the R cube part from the other one, it becomes R raised to the power 4. Rest is nothing but 1 plus R square into 1 plus R square. Now, since I want something in the powers of AR raised to the power 3, I can take this as A square R raised to the power 6 by R square. And this will become 1 plus R square whole square. Now, what I need to do is just substitute the value and get the answer. So let us quickly do that. So 6 into, this will become 1 by 9. This will become 2. 1 plus 2 whole square. If I simplify this, it comes out to be 3. That is nothing but option D. Now let us look into the next question. In this 2023 question, they have given a very interesting condition that the product of the fourth and the sixth term. So if I take my first term as A and common ratios are, the fourth term becomes AR cube into AR raised to the power 5. And this is given as 9. So what we have is A square R raised to the power 8 is equal to 9. This is given to us. Another condition says that the sum of the fifth term, that is AR raised to the power 4, and the seventh term, that is AR raised to the power 6, is nothing but 24. And now if I look into what they're asking me, they are given this first term as A into 9th term, that is AR raised to the power 8. Second term AR, fourth term AR cube, and 9th term AR raised to the power 8. And then AR raised to the power 4 and AR raised to the power 6. If I simplify this, this becomes A square R raised to the power 8. This becomes A cube R raised to the power 12. The next becomes AR raised to the power 4 and the last becomes AR raised to the power 6. these are the information that are given and what have been asked to us. So now if I look into this very concisely correctly, I do not need to solve equations to find the value of A and R. What I can just do is I can use the value of AR raised to the power 4, because from that if I square it I will be able to get this value. If I cube it I will be able to get this value, and directly I will be able to get this value. And if I get AR raised to the power 6, I can substitute in the last part of the question and get to the answer. So in order to execute this, now what we are going to do here is, we are going to find the value of AR raised to the power 4, and that comes out to be 3. Put this value here. If I do that, AR raised to the power 6 becomes 21. Put both of these values here and quickly get to the answer. If I put the values, this becomes 9, this becomes 27, this becomes 3, and this becomes 21. If you add it up, this becomes 60. So it is a very example of one of those questions which involve very intelligent calculations to get to the answers really fast. Again, this 2024 question talks about there are two distinct positive real numbers. So they are talking about A and B as two distinct numbers. Now what they are saying next is the 11th term of the GP. So we have 11th term of a GP whose first term is A and third term is B. So if I talk about this, if the first term is A, then A is already sorted out. But for B is nothing but the third term. So if I write this as R1, it is a third term, it will become R1 square. So from here I can get the value of R1. And since we are talking about distinct positive numbers, etc., let us consider it positive only. So it becomes nothing but B by A root. So you figured out R and you have figured out A. Using this, you can figure out the 11th term. So T11, if I want to find, it is nothing but AR1 raised to the power 10. You can see that this is A, this is B by A and raised to the power 10 and divided by 2. This can be easily simplified, and the answer to this becomes nothing but B raised to the power 5 by A raised to the power 4. This is the first part. In the second part, what they are saying is this is equal to pth term of another GP. So now they are talking about another GP. Pth term whose first term is A and fifth term is B. So first term is already given as A, and now fifth term. So AR raised to the power 4 is equal to B. So from here you can get the value of R2. This is B by A raised to the power 1 by 4. Now they are talking about a pth term here. So pth term, if I figured out in this new sequence, it is going to be A R square raised to the power P minus 1. So if I write it down, it is A, then this will become B by A, P minus 1 by 4 will come. Now what they are saying is this is equal to the term that we figured out earlier. So in the third step, we can equate both of them. And it would be better if I write it like this only. It will make sense for us to solve the question. So you can see that A gets cancelled out and P minus 1 by 4 came out to be nothing but 5. So P comes out to be nothing but 21. Now this 2024 question connects two very important ideas of mathematics. The first is nothing but the idea of triangle inequality, and then the second is the idea of greatest interior function. Let us see how this works out. So what they are saying in the first step is there are three successive terms of an GP. So I can take the term as A, AR and AR square. Now in the second part, what they are saying is are the lengths of the sides of a triangle. So you can see that since R is greater than 1, this is going to be the biggest one, then this, then this. So there is a pecking order between them. This is how it is arranged. We have got it. These are nothing but the lengths of the side. So if these are the lengths of the side, we can apply triangle inequality here. So the sum of two sides should always greater than the third side. Now having this into place, we can cancel out A. This will become 1 plus R, and R square minus R minus 1 will be smaller than 0. From here we will get the range of R. Now let us do that. For finding that, all we need to do here is nothing but apply the quadratic formula. It will become 1 plus minus root of B square minus 4AC, that will become 4 by 2A. So this is nothing but 1 plus minus root 5 by 2. Now see, R is greater than 1, so we can't take the minus sign. We will have to only take the plus sign. So this is the value that we are getting. Now we can see that if I talk about this number, what can be the approximate value? So root 5 is nothing but 2 point something. If I add 1 to it, root 5 plus 1 will become 3 point something. And if I divide by 2, so I will get 1 plus root 5 divided by 2, and this will become 1.5 something something. So in the third part, or the where we are applying greatest integer function, if I take greatest integer function of r, it will become nothing but 1. But for minus r, it will become nothing but minus 2. Now we have got both the values. Let us substitute in the expression that is given to us. Step number 4. So if I put the values, you can see that 3 into 1 minus 2. So answer comes out to be 1. Let us start with another problem type. This problem type 6 talks about the questions which are based on sum of GP. So for sum of GP, we have already seen there are two formulas, one for n terms and another for infinite GP. Let us try and apply those formulas in solving JEE Mains questions. So this first question of 2020 is a very simple question, talks about product of terms. Now if you write the first term here, what you are going to get is 2 raised to the power 1 by 4. If you write the second term in the power of 2, it becomes 2 raised to the power 1 by 8. Next becomes 2 raised to the power 1 by 16 till infinity. And if I apply the rules of exponent, it will become 1 by 4 plus 1 by 8 plus 1 by 16 up till infinity in the power of 2. And now you can see that what we have written in this power is nothing but an infinite GP. So let us apply the formula of a upon 1 minus r. And if I do that, this becomes 2 raised to the power 1 by 2 or root 2. That is nothing but our option A. This was a quite simple and straightforward formula based question. Now let us look into another problem. In this problem of 2021, they want us to apply this infinite GP formula multiple times. So if I want to find the value of x, summation notation is used. What does this mean is, this is the series that starts from 1. The second term is nothing but cos square theta. Next term is nothing but cos raised to the power 4 theta till infinity. So if I want to find the answer, it will become a upon 1 minus r, that is nothing but cos square theta. Similarly, if I want to find the value of y, similarly it will become 1 upon 1 minus sine square phi. Should closely observe what is the value of angle given. Sometimes student will take both the values at theta and then they will commit some error and the answers will not match. If I want to find the value of z, similarly it becomes 1 upon 1 minus cos square theta sine square phi. Now what they're asking is the relation between x, y and z. For finding that, let us find the value of cos square theta from the first part. So cos square theta can be written as 1 minus 1 by x. From here, your sine square phi can be written as 1 minus 1 by y. And now let us substitute both of these values in this last step. So it becomes 1 upon 1 minus 1 by x into 1 minus 1 by y. And then if I take LCM, something, or I open the bracket first, then I get something very interesting. It becomes 1 upon 1 minus 1 plus 1 by x plus 1 by y minus 1 by xy. So this 1 gets cancelled out. If I take LCM, it becomes xyy. X plus y minus 1. Okay. And now I can cross multiply. So this becomes z into x plus y minus z is equal to xy. Or z into x plus y is equal to z plus xy. And you can see that this matches our option 4. Now let us look into the next question. In this next question, they are talking about a very weird kind of summation of GP. They are not starting from the first term. What they are starting from is the third term, then fifth term, and they are going up till 201 first term. And the sum is equal to 200. This is what is the first condition given. And in the next part they talk about, they start with A2, then A4, and they then go up till nothing but A200, and this sum is 100. These are the two conditions given to us, and what they are asking us is, tell us the value of the sum from A1 to nothing but A200. Taken all the values at the same time. Now interestingly, if you take your first condition, it will become AR square, AR raised to the power 4 up till AR raised to the power 200 is nothing but 200. So if I want to write the sum, it becomes AR square into R raised to the power 200 minus 1 by R square minus 1. So we have applied the formula of sum of n terms of a GP. So this is nothing but 200. Similarly, this next series, if you write, can be written as AR plus AR cube, and this will go up till AR raised to the power 199 is equal to 100. And again, the first term is AR. The common difference is R square raised to the power 100 minus 1 by R square minus 1. this is equal to 100, and this r square raised to the power 100, like we did earlier, can be written as r raised to the power 200. Now, if you take this term that we wrote earlier, and if you divide it by this term that we have just got, let us see what we get. So what we get is the value of r. R becomes nothing but 2. Just by dividing my first equation by my second equation. Okay. Now, interestingly, let us look into what the question wants us to answer. They want us to find the sum up till 200 term. So if I write it, it is a into r raised to the power 200 minus 1 by r minus 1. Okay. Now, if you look into this second equation that we figured out, this is something very interesting. That from here we can get few parts of this question, and I can manipulate it into getting those parts. So now, if I multiply by r, then 200 minus 1 by r square minus 1. So you can see that I have replicated most of the parts here. Now, in order to get there, I will have to divide by r, and I have to multiply by r plus 1. If I do that, I will be able to get my answer. And this part from this equation 2, I know this is nothing but 100. And r being 2, this becomes 3 and then 2. If you simplify, this becomes nothing but 150. And by doing this smart calculation, you were able to reduce the amount of time required to solve this question and get the answer really fast. Now, let us look into this next question. And this is a very interesting question because the way it has been presented, that makes this very interesting. So in this question, in order to get the sum of this series, we need to start pairing terms. So if I pair all the first terms together, and I get an infinite GP, 1 by 2, 1 by 2 square, and this will go up till infinity. Now, from the second terms, if I take 1 by 3 common, in fact minus 1 by 3 common, again I get 1 plus 1 by 2, 1 by 2 square till infinity. And from the next one, I can take plus 1 by 3 square common. So 1 plus 1 by 2 plus 1 by 2 square till infinity. And we can keep on doing till infinity. So if I do this, this is first GP that I have. So the sum becomes a upon 1 minus r. The second becomes in the similar manner a upon 1 minus r. Similarly, the third one also becomes a upon 1 minus r. And this will go till infinity. So if I observe this pattern, the first term becomes 1, the second becomes 1 by 3 into 2, the third becomes 1 by 3 square into 2. So not till infinity. Now if I leave the first term and focus on the second one, I can take again a 2 by 3 common. It becomes 1 minus 1 by 3, then plus 1 by 3 square till infinity. Again, in this second part, we can apply sum till infinity. So a upon 1 minus 1 by r. In this case, the r is nothing but minus 1 by 3. So if I apply the formula, becomes 2 by 3 into 1 upon 4 by 3. And if you simplify this, it becomes 1 minus 1 by 2 comes out to be 1 by 2. So now this is equal to alpha by beta. Then the value of alpha is 1, beta is 2. And if I want to get the value of alpha plus 3 beta, obviously it will come out to 7. Next, we are going to discuss a very special problem types that involves combining the problems or the concepts of AP and GP in one question. And let us start with it. Now, in this first problem, based on AP and GP combined concept, you can see that we can get X, Y, and Z by directly applying the formula for infinite GP. So if I want to find the value of X, it is nothing but A upon 1 minus R. Similarly, y we can get is 1 upon 1 minus b, and z we can get is nothing but 1 upon 1 minus c. Now, there are two ways to proceed forward. Either you can take the values of a, b, c and then solve this problem. Or conversely, what you can do in this question is, you can use the properties of AP. So now what we can say is, see, if a, b and c are in arithmetic progression, then minus a, minus b and minus c will also be in arithmetic progression. So if I am taking 1 minus a, 1 minus b and 1 minus c, this will also be in arithmetic progression. And now if I take their reciprocal, so now if I am talking about their reciprocal, so if I am saying that this is equal to 1 by x, so 1 by x, 1 by y and 1 by z will also be in arithmetic progression. So I have taken this 1 by a as 1 by x using this first equation, second equation, third equation. So C option becomes correct. Now let us look into the second question. In this second question, they are giving two conditions. One is a cube, b cube, c cube are in arithmetic progression, and then log of B to the base A to the base C to the base B are in nothing but GP. So first let us use the condition of GP because that will give you better insights. So if three terms are in GP, then B square is equal to AC. So log of A whole square will be equal to log of B to the base C and log of C to the base B. Now let us use base change formula. So if I use base change formula, it will be log of A by log of C whole square. This I can write this is log of B by log of C and into log of C by log of B. So this log B gets cancelled. And if I simplify it, it becomes log of A whole cube is nothing but log of C whole cube. That implies log of A will be equal to log of C, and that implies A will be equal to C. This is the first very important thing that we are getting in this question. Now, if you look into the AP condition, so if A is equal to C, then A cube will also be equal to C cube. Hence, this can only happen when A, B and C become equal. Only then the AP condition will become true. Otherwise, it will not become true. Now, once we have gone from there to here, now they are talking about another series. Now, in this series, what they are saying is the first term is equal to this. So let us also write that another series that they are talking about. So if I take this alternative series, they have given the capital A is nothing but A plus. So I am taking all as A, B and C also. So this becomes 6A by 3. So it becomes 2A. And if I want to find D, they have given as A minus 4 times A plus A by 10. Again, I am taking A, B, C all equal to A. Once I do that, what I am getting is nothing but, here it is 8. What I am getting is minus 6A by 10 or minus 3A by 5. Now, once you have done that, what they are saying is if I take the sum of 20 terms, so sum of 20 terms will become 20 by 2, twice of A, and then A in this case was nothing but 2A. So let us take that also in consideration. So this will become 4A plus N minus 1, that is 90, and D is nothing but minus 3A by 5 is equal to minus 144. This is given to us. So now our task is very simple. Find the value of A and from there get the value of A into B into C. Right. So if I simplify this, this becomes 10. And if I divide by 2 on the both the sides, this becomes 5. This becomes minus 2, 2, 2. If I multiply this 5 inside, this becomes 20A plus 19 into minus 3A will be equal to minus 2, 2, 2. And if I go further and simplify, this will become minus 37A. If I take both the terms, is nothing but minus 2, 2, 2. So A as a result comes out to be 6. Now what they are asking is what is the value of ABC? That would be nothing but 6 cube. And 6 cube is nothing but 216. You can see that there are two parts of the question. First part talks about GP and AP. So the GP condition gave us that A is equal to C. If I put that condition into AP, I get A is equal to B is equal to C. Then there is an alternate condition. And now again, another kind of series they are talking about in terms of capital A and capital D. We apply the sum of the series and get the answer from there. Now this next question is very interesting. Let us look into it. So it talks about two positive numbers A and B. And it has been given that A, B and 18 are in GP. So if three numbers are in GP, we can write B square is equal to AC. So B square A into 1 by 18. This is the first condition. They're also saying that 1 by A, 10 and 1 by B are in arithmetic progression. So three numbers in the arithmetic progression ABC would mean 2B is equal to A plus C. So 2 into 10 will be equal to 1 by A plus 1 by B. So you can getting this value as 20. This is 1 by A plus 1 by B. This is second condition. If you take the value of A and substitute it here, it will become 20 plus 1 by 18B square plus 1 by B. Now, usually answers of such questions are in integer only. So either you can solve the quadratic equation in 1 by B, and that is one valid way to do it, or you can be little bit intelligent and think about what can be the fractional values of B. So I'm thinking in terms of something which is a multiple of 6 so that 18 gets cancelled out. So 1 by 6 I tried did not work out. 1 by 12 is working out. So if I take 1 by 12, what you can observe here is by putting this value, your right hand side becomes 12 square by 18 plus 12. And if you simplify this, this first part becomes 12 into 12 by 18, 6 into 2, 6 into 3, 3 into 4. So 8 plus 12 becomes nothing but 20. So it gets satisfied. So this is hit and try, but it will make your calculations really fast. So once you are able to observe that, now let us find the value of a from here. So a is nothing but b square into 18. So if I write b square into 18, it will become again, okay, from the last part also you can guess, but let us do it. Here b square was nothing but 1 by 12 square, and into 18 if you do, the value of a comes out to be nothing but 18 by 12 square. We just did it, it is nothing but 8. So 12 into 12, 6 into 3, 6 into 2, 3 into 4, a becomes 1 by 8. Now we have got the value of a also, b also. Let us put in the expression that is given to us, 16a plus 12b. So if I do this, if I put this into 16a, a is nothing but 1 by 8, and 12b, b is nothing but 1 by 12. Answer that I get is 3. If I look into this next 2024 question, it is an extremely interesting question. It talks about a recurring process. So let us trace it down. What they are saying is you have a triangle, an equilateral triangle for that matter. And if you have this triangle, we will take the midpoints of the opposite sides and we will join and make one more triangle. And this process will go on forever. Now what they want us to figure out is the value of P, that is nothing but the sum of parameters of all such triangles, and Q, that is nothing but the sum of areas of all such triangles. This is what we want to do. So once you have this, let us do it very systematically. So if you can see that if it is an equilateral triangle and if you do this construction, the angle, this angle will remain 60, this will also become 60, this will also become 60. As a result, if this is nothing but the midpoint and this part becomes a by 2, the other triangle is also equilateral, this will also become a by 2, so on and so forth. So we are getting equilateral triangles inside equilateral triangles. That is what is happening. First thing to be noted. Now if I move from here, you can see that if I want to write the parameter of the original one, it is going to be equal to 3a. Now from the next part, you can see that the side became half, so it is going to become 3a by 2. And now this process will continue till infinity, giving us an infinite GP. Answer of which becomes 3a divided by 1 minus 1 by 2, a upon 1 minus r, so that becomes 6a. The value of this is nothing but p. This is the first part of the question. If I move towards the next one, in which we want to find the area of the original triangle will be nothing but a root, what we can say, half of square of sides and the angle between them, half of AB sine theta. Now you can see that if I am doing in the next round, since the side becomes half, angle did not change, it will become 1 by 2 a square sine 60 degree, and this cycle will continue. So if I want to find the sum now, and this sum is given as q, the answer becomes a, that is nothing but root 3 by 4 a square divided by 1 minus r, then the situation will become 1 by 4. So if I simplify this, this becomes a square by root 3. We have got the value of P and Q. What we can do in the next step, we can substitute the a from the first equation, and if I do so, Q will be nothing but P by 6 whole square by root 3, and that measures up to P square is equal to 36 root 3. Let us check the option. You can see that the B option matches. If I talk about this next question, it is again an extremely simple question. Question says that there are 64 terms in a geometric progression. What we need to do is the sum of all the terms. If I do sum of all the terms, it will become a into r raised to the power 64 minus 1 by r minus 1. It is equal to 7 times the sum of odd terms. Now if you look into the odd terms, it is a, then ar square, then ar raised to the power 4, so on and so forth. If you want to write this, first term will remain a, but common ratio becomes r square. There will be 32 such terms divided by r square minus 1. This is what we will end up with. Once you have ended up with this idea, you can see that the numerator gets cancelled out. So what we are left with is nothing but 1 upon r minus 1 is equal to 7 by r minus 1 into r plus 1. And once I have done this, r minus 1 will get cancelled out. R plus 1 is equal to 7, r comes equal to 6. You can see that B option matches. Let us move towards another problem category, that is properties based on questions based on properties of GP. Now, first I'm going to tell you in very short what are the important properties of GP that we are going to use in solving questions, and then systematically we are going to take recent pattern of questions based on it. So let us start with it. So first is regarding assumption of terms. So only assume terms. This is the first and the most important thing. Only assume terms if they are talking about product of the terms in the question. Otherwise, it is a wastage of time. This is the most important idea. Now, if you want to assume three terms, you can assume that as A by R, A and AR. So these are three terms. So you can see here the common ratio is nothing but R. For four terms, you will take A by R cube, A by R, AR and AR cube. So you again see here that now the common ratio is nothing but R square. So these are two, and in fact three very important ideas that you are going to use in solving problems. So next property is nothing, properties in which we have constants and operations with GP. So let us take an example in order to understand it faster. So if I take 1, 2, 4, what you can observe is if I add 5 to all the terms, it becomes nothing but 6, then 7, and then 9. So no more in GP. If I subtract 5, again you can see that this will become -4, -3 and -1, again not in GP. But if I multiply with 5, something magical happens. It becomes 5, 10 and 20. You can see that it is again in GP and the common ratio remains same. Only the first term has changed, has become 5 times, and the common ratio still remains same. If I divide by 5, again what you will observe is this becomes 1 by 5, 2 by 5 and 4 by 5. Still you can see that the first term has changed, but the common ratio has remained same. So in addition subtraction, it will no more be in GP. For multiplication division, it will be in GP, just the first term will change. Now what happens if I take log? So if I take log, this becomes log of 1, log of 2, log of 4. So this one is 0 only, and this becomes log 2, and this can be written as 2 log 2. So what you can observe is now it has become an arithmetic progression. So if you take log on a GP, it becomes an AP. This is a very important thing. So we have done the first three properties. This was the first property, this was the second property, this is the third property, and the fourth property goes ahead and says that if I raise the numbers to the power, so if I do 1 square, 2 square, 4 square, now you can see that what has happened is the initial term, first term becomes A square and R square. The common ratio also becomes R square. So whatever power you are going to raise, the same power will also be taken by A and R. This is a very important idea. Now in the fifth part, what they're saying is if you multiply two GPs, let us say 1, 2, 4 and 3, 6 and 12. If you multiply both of these, what is happening is now their first term will be multiplication of both the terms, and their common ratio will also be multiplication of both the common ratios. Now next is the concept of means. Now in this concept of means, you can see we divide the property into two parts. The first part is how to take a mean of two terms. So if you have two terms A and B, their mean would be nothing but root of AB. If you have three terms like A, B and C, their mean would be A into B into C raised to the power 1 by 3. This is the answer. And now if I do the same process for n terms, I can write a similar result like A1, A2, A3, AN. If I want to find that, I am going to multiply them till AN and put 1 by n in the power. So this is the concept of means. So if you have to take mean in GP, this is what it means. Now there are some interesting properties to it. What are those interesting properties? The first thing is that if I am taking 1, 2, 4 and 8, so if I have to take the mean of all the terms, let us say 1 more 16. So if I take mean of all the terms, I will get the middle term. So I will get this term. If I take mean of 2, 4 and 8, still I get 4. If I take it for 2 and 8, I get 4. So you can see that equidistant terms are behaving, from the ends are behaving in the similar manner. This is a very interesting property. And the fourth is about inserting AMs, inserting GMs. So what we are saying is, let us say we have 1 and 8 and we want to insert two geometric means between them. This is exactly what we did with AP. So what does this mean now? A, G1, G2 and 8 are going to be in GP. So if I consider this phenomena, only thing that we do not know is R, and in GP, R is very important. So R we can find using the last term. So it becomes 8 into A into R raised to the power 4 minus 1. So you can see that the value of R cube comes out equal to 8 and R comes equal to 2. And this is important because now G1 would be equal to AR and G2 will be equal to AR square. You can put the values and get the answer. So this is the concept of inserting GMs. Now all of this has been summarized in the form of a table. So if you want to take a screenshot or take notes of this, it is very important. It will help you out. Now let us look into another problem category, that is questions based on geometric means. So I have already talked about these properties. Let us look into the question based on this idea. So question was asked in JEE 2020 that talks about M arithmetic means being inserted between 3 and 243 and 3 geometric means inserted between them, and they have given this condition and asked that what will be the possible value of M. So let us first insert the 3 geometric means. So there is 3 geometric mean 1, 2, 3 and then 343. So if I want to find the value of R, I can write 243 is equal to A into R raised to the power 5 minus 1. So if you solve this, this is 81 is equal to R raised to the power 4, R is equal to 3. So once you've got the value of R, now you can get the value of G2. So G2 is nothing but AR square, or A was 3 and R is also 3. So this becomes nothing but 27. Now let us go into the domain of arithmetic means. Now what they're saying about arithmetic mean is, if I have M arithmetic means, then 3, A1, A2 like this, then we will go till AM and then 243 will come. So if I want to find the value of D, it is going to be A plus M plus 2 minus 1 into D. So the value of D comes out to be 240 by M plus 1. This is the value of D we are getting. So if I want to find the value of the fourth arithmetic mean, it is going to be A plus 4D. A is nothing but 3. 4 into D is nothing but 240 by M plus 1. Now they are saying that this A4 is equal to nothing but 27. So let us equate this to 27. So 3 plus 4 into 240 by M plus 1. So 24 is equal to 4 into 240 by M plus 1. And you can see that the value of M plus 1 is coming out to be 40, or M comes out to be 30. So quite a simple question. If you know the concept, you can easily deliver this question. Now let us look into this next question. This next question is very intelligently framed on the properties of GMs and AMs. So now if we have 3 GMs between A and B, then we have A, G1, G2, G3 and then B. Fine. So I want to find the value of R from here. B will be equal to A times R raised to the power 4. Or B by A is equal to R raised to the power 4. This is very interesting fact, because now we are going to use this to substitute in the option. So here if I write this first, G1 is nothing but AR raised to the power 4. G2 is nothing but AR square raised to the power 4. D3 is nothing but AR cube raised to the power 4. And this is nothing but AR raised to the power 2 into AR square AR cube raised to the power 2. If we do this, now why are we doing this? Because once you do this, you realize that this term and this term comes out to be equal. It is bound to be. Using property also we can conclude that. So now we have A raised to the power 4, R raised to the power 4. 2 times A raised to the power 4, R raised to the power 8. And A raised to the power 4, R raised to the power 2. This came because these two are equal. You can calculate and check. So once you have done that, what you can observe is from here, we can put the value of from r raised to the power from above. So it becomes b by a raised to the power 4 b square by a square, and a raised to the power 4 b cube by a cube. And if you do this very simple substitution, what you get from here is a cube b 2a square b square plus a b cube. And if I take ab common, this becomes a square plus 2ab plus b square. That can be written as ab into a plus b whole square. Now you can just look into the options and get the answer. How? Because we have property that if I take the mean of terms equidistant from the end. Now let us see this terms of arithmetic means. So this is what we have in terms of arithmetic means. So if I take arithmetic mean of a1, a2, it is going to be equal to ab. Arithmetic mean of ab. So a1 plus a2 by 2 will be equal to a plus b by 2, or a1, a2 is equal to ab. So if I just look into my option A, I can directly get my answer. So option A, if I look into it, a1 plus a2 can be written as nothing but a plus b. And similarly, if you write g1, g3, it is going to become ar, and ar cube again, you can see that this is coming out to be a square r raised to the power 4. R raised to the power 4 was nothing but b by a. You can see that this becomes ab. So again, if you check this option, and it is coming out to be a plus b whole square into ab, hence this becomes R. You can check other options also, and apart, if you use the similar logic, the calculation is not very difficult. Now let us look into this next question. Quite simple question. What you have to do is just substitute the value and get to the answer. So now they have given this condition and all the terms are in geometric progression. So we can assume a and r in this question. So if I write the first term, this first condition, it becomes a into ar square into ar raised to the power 4 and ar raised to the power 6, and is equal to 1 to 1 by 1296. And we all know that 1296 is nothing but 6 raised to the power 4. If I write the terms on the left hand side, it is a raised to the power 4 and r raised to the power 12 is equal to 1 by 6 raised to the power 4. So a r raised to the power 3 will be equal to 1 by 6. This is first condition. Now if I look into the another condition that is given is a4 plus a2 is equal to 7 by 36. a2 is nothing but ar and a4 is nothing but ar cube, and this is 7 by 36. This value I can substitute. So ar plus 1 by 6 is equal to 7 by 36. So ar comes out to be 1 by 36. Now if I divide both of these, I get the value of r square, and that is nothing but 6. So these are the three informations available to me. Now let us see what they have asked from us. So what they have asked from us is nothing but find the value of this expression, that is a6, that is ar raised to the power 5, a8, ar raised to the power 7 plus ar raised to the power 9. Okay, so if I take ar cube common, it becomes r square, r raised to the power 4 and r raised to the power 6. Now ar cube value we already know. Ar cube is nothing but 1 by 6. ar square is 6, so this becomes 6, this becomes 36, and this becomes 6 cube, so 216. If I simplify this, this comes out to be 43. Now let us look into another question based on similar type of concept. Now what they are giving this question is 1 by x, 1 by y, 1 by z are in arithmetic progression. What would that mean is 2 by y will be equal to 1 by x plus 1 by z. This condition we know. So if I simplify this, this is nothing but x plus z by xz. This is what we will get. Another condition is given that x, root 2 y and z are in geometric progression. That would mean root 2 y whole square will be equal to xz. So 2y square is equal to xz. So I can use this condition and substitute it here. If I do that, 2 by y is equal to x plus z is equal by 2y square. So what we get is nothing, x plus z is nothing but 4y. Now apart from that, they have given us another condition what is the another condition? Let us look into this. This condition talks about a relation between x, y, y, z, zx. If I divide this x by z on the left hand side, it becomes 1 by z plus 1 by x plus 1 by y is equal to 3 by root 2. Now this is a very interesting condition because see again from this first condition, I can substitute the values here and this becomes 2 by y plus 1 by y is equal to 3 by root 2. We can cancel out these 3 and y becomes nothing but 2. Once y becomes root 2, we can substitute and get the value of x into z. That is nothing but 2 into 2. So xz is nothing but 4. And also we can get the value of x plus z, that is nothing but 4 into root 2. Now in order to solve this, the solution is not very difficult. We can substitute the value of z here. So z is nothing but 4 by x. X plus 4 by x is equal to 4 root 2. So x square plus 4 is equal to 4 root 2 x, or x square minus 4 root 2 x plus 4 is equal to 0. And once you solve this quadratic equation, the value of x comes out to be 2 root 2 minus 2. From here, the value of z comes out to be 2 root 2 plus 2. Now let us go into the question part. Question says that find this value. So what they're asking us to find is nothing but 3 times x plus y plus z whole square. So we already know the value of x now, 2 root 2 minus 2. Y was nothing but root 2 and z comes out to be 2 root 2 plus 2 whole square. And if I do this, what we get is 5 times root 2 whole square into 3. This if you calculate comes out to be 1/5. It's not a very difficult question, and what you need to do is use the same condition multiple times to get to the answer. Now this is the very interesting question. This question talks about that the arithmetic mean and geometric mean of pth and q term of a sequence this. Now if you look into this sequence, the common ratio is nothing but minus 1 by 2 and a is nothing but minus 16. So this is nothing but a GP. Now they are talking about that the pth and qth term. So the pth term would be nothing but a r raised to the power p minus 1 and the q term would be nothing but a r raised to the power q minus 1. So now the two roots are nothing but am and gm of this. So it is a little bit complicated there. Okay, so an easy way to go about this would be to find the roots and work backwards rather than going in the forward direction. So if I find the roots, x would be equal to 9 plus minus root of b square, that is 81, minus 4ac by 2a. If I do that, this becomes 9 plus minus 1 by 8. You can see that one of the root comes out to be 10 by 8 and another root comes out to be nothing but 1. Now see, the smaller root is going to be the GM and the greater root is going to be the arithmetic mean, because AM is always greater than or equal to GM. So I will have to consider this root. So if I consider this root, what they are saying is the square root of a r raised to the power p minus 1 into a r raised to the power q minus 1 should be equal to 1. So if I do this, what you can observe from here is nothing but a square r raised to the power p plus q minus 2 will be equal to 1. So now a square here would become nothing but 16 square, and this is minus 1 by 2 raised to the power p plus q minus 2 equal to 1. If you simplify this, very simple idea, so you will get the value of p plus q as nothing but 10. Quite simple to do. Now this next 2024 question talks about 3 numbers ABC that are nothing but in arithmetic progression. So if I want to solve this question, I can use this idea along with another idea that they have given. Arithmetic mean of ABC is equal to 8. See, if ABC are in AP and their arithmetic mean is equal to 8, that would mean the middle term will become arithmetic mean and that is given as 8. This is the first thing that you can directly understood from here. If you can't understand, you can take the value of A and then b as a plus d, c as a plus 2d, and then do the same thing, we'll get the same answer. If you can understand this, and if I assume d to be common difference, then a will become nothing but 8 minus d, and c would be nothing but 8 plus d. So we have figured out this in the first two steps. Now what they're saying is there are another set of numbers that are in nothing but GP. A plus 1 will become 9 minus d, b will remain 8, and c plus 3 will become 11 plus d. So now these three numbers are in nothing but GP. That would mean b square is equal to AC. So 8 square should be equal to 9 minus d and 11 plus d. So this becomes 64. This becomes 99 plus 9d minus 11d minus d square. So if I simplify this, the quadratic equation in d square becomes d square plus 3d plus 2d. And then if I subtract, this becomes nothing but minus 35 is equal to 0. This factorizes itself into d plus 7 and d minus 5 equal to 0. So there are two probable values of d. One of them is minus 7 and another one is nothing but 5. Once we have got this, in the next step, in the fourth step, what we are going to do is a very interesting thing. If I figure out the value of a, they have given that a needs to be greater than 10. See, a greater than 10 is only possible if I consider the value of d as nothing but minus 7. So this condition gives us the value of d, that is minus 7. So now correspondingly the value of a comes out to be 8 minus 7, this will become nothing but 15. B already was 8 and C comes out to be nothing but 1. So you have got this. In the next part or the fifth part, they are asking nothing but the GM. The GM will become ABC raised to the power 1 by 3. They are asking the cube of this. So fundamentally they want us to tell the value of A into B into C. That comes out to be 120. So A option comes out to be correct. Now this 2024 question is an extremely simple question. If you want to solve this question, you need to consider two cases. In the case 1, what they are saying is A is the greatest one. This expression is given. See, one root you can already see by observation that if I put x equal to 1, left hand side will be equal to 0. So it will automatically satisfy. So they are telling us that alpha is not equal to 1. Now what they are saying is if there are two things they are assuming. B cannot be in geometric progression, then this happens. Or B is in geometric progression, then this happens. So let us take two cases. In first case, let us take B as geometric mean of A and C. So I can take the value of A as 4, the value of B as 2, and the value of C as nothing but 1. If I consider these values, you can see that A plus B minus 2C. So A plus B will become 6, minus 2 will become 4. So your coefficient of the first part becomes 4. Plus in the second part B plus C. So B plus C will become 3 minus 8, that will become minus 5 times x. And ultimately the C part, that is A plus C, so 5 minus 4, this becomes 1 is equal to 0. This is what is given to us. Now you can see that this can be easily written as 4x minus 1 into x minus 1 equal to 0. If I do this, you can clearly see that the two roots will be nothing but 1 and 1 by 4, and they have told that this is not alpha. So obviously alpha becomes 1 by 4 and that lies between 0 and 1, so second statement becomes correct. Similarly, for checking the other statement, we can take them not in GP. So you can take them as 3, 2 and 1 and then verify the statement 1, that also comes out to be true. So B option becomes correct, both 1 and 2 are true. The 10th problem type is nothing but based on AM is greater than equal to GM. So what is this idea? Idea says that if you have two terms, A and B, then for those two terms, the condition is both of them needs to be positive. AM is greater than equal to GM cannot be applied for negative terms. This is very important. So AM becomes A plus B by 2 and GM becomes root of AB. I can also apply the similar idea for n terms. If I consider A1, A2, A3 till AN, still the idea remains true. Condition is they needs to be positive. So if you have A1 plus A2 until AN, by n, this is going to be greater than equal to nothing but A1, A2 multiplication till AN raised to the power 1 by n. Except the equality comes when the terms become equal. So this equality will come when A is equal to B. This equality will come when A1 is equal to A2 up till AN. And then at this point, the AM will take its minimum value and the GM will take its maximum value. And see, the important idea is not just this, the concept of AM is greater than equal to GM. The hint in the question will come from terms given positive. So this is usually the hint in the question which will give you the way forward to apply this idea. Now let us see through question how to apply this idea. Now this idea has been asked in JEE exam in 2-3 different ways. Let us try and understand that. So the first way of applying this idea is nothing but something like a weighted mean kind of a situation. Like in this question, if you look into it, what they're asking is a raised to the power 5 b cube c square d. So what we are saying is, if I take 5 a by 5 terms, so a by 5, a we are splitting into 5 different parts, so a by 5 we are taking 5 times. And then similarly b by 3 3 times, and then c by 2 2 times, and d 1 time. So these are total, if you look from here to here, there are total 11 terms. And now in this 11 terms, since all of them are positive real numbers, this is the hint in the question, we can apply m is greater than equal to gm. So if I do that, a by 5 plus a by 5 5 times, plus b by 3 plus b by 3 plus b by 3 plus c by 2 plus c by 2 plus d, by, since there are total 11 terms, this is going to be greater than or equal to a by 5 raised to the power 5, c by 3 raised to the power 3, sorry, b by 3, and c by 2 raised to the power 2 into d raised to the power 1 by 11. Got it. Once you have done this, your life becomes very easy, because whatever is written on the numerator, this 5 a by 5 will become a, 3 b by 3s will become b, then c and d divided by 11 is always greater than equal to a raised to the power 5 b cube c square into d, by nothing but 5 raised to the power 5, 3 raised to the power 3, 2 square raised to the power 1 by 11. See, now the numbers are given in such a manner that a plus b plus c plus d is equal to 11. And this will benefit us while solving the problem. And now if I put this value as 11, so this 11 by 11, a raised to the power 5 b cube c square d, by 5 raised to the power 5, 3 square, 3 cube, 2 square raised to the power 11 will be smaller than or equal to 1. So the maximum value of a raised to the power 5 b cube c square into d, this is always smaller than or equal to 5 raised to the power 5, 3 cube and 2 square. So the minimum value is this. Now what they've given is 5 raised to the power 5, 3 cube, 2 square should be equal to 3750 into beta. Now this can be easily solved. If you factorize it, the value of beta comes out to be 90. Now in this question, they are playing with the same idea but in slightly different manner. Now let us see that. Now in this question, what they have given the question is x into y is greater than 0. This is the hint to apply m is greater than equal to gm. Now since they are talking about x cube y square 3x to y, it makes sense that we take 3x's and 2 y's and then apply m is greater than equal to gm. So x plus x plus x plus y by 5 is greater than equal to x cube y square raised to the power 1 by 5. Okay, so if I look into my left hand side, it is 3x plus 2y by 5 is greater than equal to x cube y square value they have given in the question as 2 raised to the power 15. Let us substitute this value. So what do we get is 3x plus 2y by 5 is greater than equal to 2 raised to the power 3, or 3x plus 2y is greater than 8 into 5, that is 40. So quite a simple question, but this idea of weighted, same things getting repeated again, has been asked in JEE twice. Now again a very simple question. Now if you look into a raised to the power a raised to the power x, obviously the quantities are positive. So again we can apply m is greater than or equal to gm between a raised to the power ax and another quantity is a raised to the power 1 minus a raised to the power x. So we can write a into a raised to the power x plus a into a raised to the power 1 minus a raised to the power x by 2 is greater than or equal to a raised to the power a raised to the power x and into a raised to the power 1 minus a raised to the power x raised to the power 1 by 2. Okay, so if I do that, I get my fx on the right hand side divided by 2 is greater than or equal to, if I multiply, becomes a raised to the power 1 by 2. So my fx is always greater than or equal to 2 root a. So my answer becomes fourth option. Now again a very conceptual and simple question. They are asking the minimum value of this function. Again the terms involved are both positive, so a greater than or equal to gm can be applied. So now we already learned this, that if we have two quantities a and b, then a plus b by 2 is always greater than or equal to root of ab. So the minimum value of this part will come when a is equal to b. So if we have two terms, in place of a we have 2 raised to the power sin x, in place of b we have 2 raised to the power cos x. Divide by 2 is always greater than or equal to root of 2 raised to the power sin x into 2 raised to the power cos x. Now the minimum value of this left hand side will come when 2 raised to the power sin x becomes equal to 2 raised to the power cos x. And that is going to happen when sin x is equal to cos x. So there are two values possible. One of the possible values is this happens when it becomes 1 by root 2. Another value then it is possible is minus 1 by root 2. Okay. So if I consider my first value, the answer comes out to be 2 raised to the power. So for our function 2 raised to the power sin x plus 2 raised to the power cos x. So one answer comes out to be 1 by root 2 plus 2 raised to the power 1 by root 2. So that is nothing but 2 into 2 raised to the power 1 by root 2 or 2 raised to the power 1 plus 1 by root 2. And another answer of the same question will come when the sin x and cos x becomes minus 1 by root 2. So 2 raised to the power minus 1 by root 2 plus 2 raised to the power minus 1 by root 2. So it comes out to be nothing but 2 raised to into 2 raised to the power minus 1 by root 2 or 2 raised to the power 1 minus 1 by root 2. Now this is a more relevant answer because we are looking for a minimum value. So our answer becomes 1 minus 1 by root 2. Now let us look into one last question based on similar idea. What you can look into this question is, this is like mixture of 2-3 concepts. So one, they are saying that these 3 terms that are given to us are nothing but in AP. So 2 times fx should be equal to nothing but 2 raised to the power 1 plus x. 1 minus x, this is one term, first term, and the last term. So what we are trying to say is 2b is equal to a plus c. So this becomes 3 raised to the power x, 3 raised to the power minus x. Now next what they are saying is they are talking about minimum value of this fx. Here our aim is greater than or equal to gm will come into place. Because what we can say is minimum value will come when both of these are minimum. Now for some common value of x. So now if you look into this first 2 raised to the power 1 plus x, this will take minimum value of this is equal to this part. And this can only happen when 1 plus x is equal to 1 minus x. So you can see that x comes out to be 0. Similarly, if for this value, you can see that 3 raised to the power x and 3 raised to the power minus x will also become same. And hence, this will also take minimum value. So what we can say is the minimum value will arrive when x is equal to 0. So this becomes 2, 2, 1 and 1. So the value of fx, that is minimum, comes out to be. Now this very interesting question came in 2024. This question talks about these 3 terms when they are in arithmetic progression. That would mean if I write the basic condition, then twice of b, that is nothing but the middle term, should be equal to sum of the extreme terms. And if I write it so, I get a very beautiful relation that I can utilize. So now left hand side becomes k But if you look at the right hand side, it becomes 4. 4 raised to the power x plus 1 by 4 raised to the power x. It will be equal to 4 raised to the power 2x plus 4 raised to the power minus 2x. Now, for the sake of simplicity, if I take 4 raised to the power x as nothing but t, then this first term that is written here will become nothing but t plus 1 by t. And the term that is written here will become nothing but t square plus 1 by t square. The benefit of doing so is t plus 1 by t square can be in turn written as t plus 1 by t whole square minus 2. Also, we should remember that t plus 1 by t, since the value of x is greater than or equal to 0 and these are positive, from am is greater than or equal to gm, t plus 1 by t will always be greater than or equal to t into 1 by t raised to the power 1 by 2. So you can see that t plus 1 by t is always greater than or equal to 2. This is important. This will become eventually very important. So now if I substitute the value, let us see what happens. So you can see that k will come out to be nothing but 4 times t plus 1 by t, and the second part becomes t plus 1 by t whole square minus 2. So ultimately, if I in the next step replace t plus 1 by t with nothing but u, then we have got a quadratic expression. So k looks like this, 4u plus u square minus 2. And now in order to get the minimum value, what they're saying is the least value of k. Let us make it a perfect square. So this comes out to be u plus 2 whole square minus 6. Now you can see that when we wrote the value of t plus 1 by t, this is u only, and u will be greater than or equal to the minimum value it can take is nothing but 2. If I put it here, this will become 2 plus 2 whole square minus 6. So answer comes out to be 10. Now let us look into next problem type. These are the questions which are based on the combination of properties of log and sequence. Let us look into one of such questions. Now in this JEE 2020 question, you can see that there is log and infinite GP involved in the same question. So if I look into this question, what I can do here is basically in the power inside the log, we can apply the formula of infinite GP. It comes out to be a upon 1 minus r. And if you simplify, it is 0.16 raised to the power log of 2.5, and this if you simplify becomes 1 by 2. Now you can use the ABC formula. Let me remind you what is ABC formula. So if we have a log c to the base b, then this is equal to c log a to the base b. ABC formula. I call this as ABC formula. This is a very common result. So if I use this, this 1 by 2 will come below and this 0.16 will go inside. Now, why are we doing this? Because now let us focus on this part of the problem. Okay, that is log, because now we are going to use properties of log. We have already used one, we are using it more. So if I look into this part, what you can say is 2.5 can be written as 5 by 2 and 0.16 can be written as 16 by 100. If I divide by 4, it is 4 by 25. So you can see that this becomes log of 2 by 5 whole square. This is 5 by 2. We can further simplify and write this as 5 by 2 raised to the power minus 2 to the base 5 by 2, and the answer comes out to be minus 2. So what was written in the power, that has now become nothing but minus 2. So this becomes 4. So the answer to this question comes out to be 4. Now let us look into this next question. Again, it tries to combine both the ideas. Let us see. So in this question, if I start from this part, that they have given this arithmetic progression whose first term we know is nothing but 3 and the common difference is nothing but 1 by 2. So if I want to write the second term, it is going to be a plus d. So this is going to be 3 log x to the base y. Okay, so if I take the things on the left hand side, it is going to be 7 by 6 is equal to log of x to the base y. That can be written by base change formula as log x by log y. Fine. In the similar manner, if I look into the third term, it is going to be 3 plus 2 into 1 by 2 is equal to nothing but 3 log y to the base z. And again, if I simplify, this is 4 by 3 is equal to log y by log z. And again, if I look into the third part or the last term, it is 3 plus 3 by 2 is equal to 7 log z to the base x. And if I again simplify, this would become 6 plus 3, 9. 9 by 14 is equal to log of z by log of x. Now, if you look into this, your log x, log y, log z can be written as in the ratio of nothing but 14, and in the base of here we can write as 12, and here nothing but 9. Now, once I get these ratios, it is very simple that if I want to assume, I can assume this equal to, let us say, nothing but k. So x would be nothing but 10 raised to the power 14k. Y would be nothing but 10 raised to the power 12k, and z would be nothing but 10 raised to the power 9k. Once I've got these results, I can use and substitute this in the first part of results that were given to me. So you can see that now if I replace x, so this becomes 10 raised to the power 14k pq square. This would be equal to 10 raised to the power 12k qr, and this is equal to 10 raised to the power 9. This was 9, yes, 9k p square r. So if you compare the powers, what you're getting is 14 pq square is equal to 12 qr is equal to 9 p square r. If I simplify the first part, it becomes 7 times pq is equal to 6r, and one more result is given, r is equal to pq plus 1. So pq can be written as r minus 1. So from here, if you find the value of r, it comes out to be 7. And now I have two more results with me. What are two more results? If I compare the other two parts, what you get is 12q is equal to 9p square. And again the value of pq is equal to r minus 1 is given as 6. From here, if you solve, your p comes out to be 2 and q comes out to be 3. And if you find the value of r minus p minus q, it comes out to be 7 minus 2 minus 3. That is nothing but 2. D option. So let us move towards this last question of our discussion. In this question, there are two parts of the question. One is based on determinant, another one is based on logarithm. So first, let us see the logarithm part of it. What they're saying is these three terms are in arithmetic progression. So what we can do is we can write 2 times log of 4 raised to the power x minus 2 is equal to nothing but 1 plus log of 4 raised to the power x plus 18 by 5. If I apply the properties of log, this can be written as log of 4 raised to the power x minus 2 whole square. And this 1 also can be written as 10 to the base 10. So here base 10 have not written, but it is assumed that the base is 10 only. So log of 4 raised to the power x plus 18 by 5. If I simplify, the left hand side becomes 4 raised to the power x minus 2 whole square. And the right hand side becomes 10 times 4 raised to the power x plus 18 by 5. And now if you compare whatever is inside, what you get is 4 raised to the power x minus 2 whole square. is equal to 10 into 4 raised to the power x plus 18 by 5. And from here, it becomes a quadratic equation in 4 raised to the power x. Now I'm writing 4 raised to the power x as t becomes 10 times t plus 18 by 5. And if you do this, t square minus 4t plus 4 is equal to 10t plus 18. And you get a quadratic equation t square minus 14t minus 36 plus 4 equal to 0, or t square minus 14t minus 32 equal to 0. So from here, the valid value of t that you get is nothing but 16. And 4 raised to the power x is equal to 16. That means x will be equal to 2. Alright. So we have solved this. Now this is the first part of the question. In the second part of the question, we'll deal with this determinant. And this is quite simple part because you have to just put the value. So this becomes 2 into 3 by 2. This becomes 1. This becomes 4. 1, 0, 2, 2, 1, 0. And this becomes a very simple determinant wherein the first row becomes 3, 1, 4, 1, 0, 2 and 2, 1, 0. And if you simplify this, the answer comes out to be 2. If I look at this next 2024 question, it talks about a series that is given in the form of log. See, now this is interesting. In the first part, what you can observe is if you have log of a, log b, log c are in arithmetic progression, 2 times log of b to the base e will be equal to log of a to the base e plus log of c to the base e. So important thing that we'll notice here is this will reduce itself into nothing but GP. So if the numbers in log are in arithmetic progression, then the numbers inside would be in GP. This is an important idea because this concept is again used in second part of the question. And here you can see that using similar logic, a by 2b, 2b by 3c and 3c by a, this will also be in GP. Similar logic. Once you figured this out from the first part, we can put b as nothing but AR and c as nothing but AR square. This is important. If I substitute this here, this will become a, this will become AR. This is 2AR by 3 times AR square, and the last part would be nothing but 3 times AR square by a. So you can see that a gets cancelled out, and what we have is 1 by 2R, 2 by 3R and 3R square. Now again, if I apply the logic, you can see that it will become 2 by 3R whole square will be equal to 1 by 2R into 3R square. So if you carefully observe, this R will get cancelled out, and what you have got is 4 by 9R square. This is equal to nothing but 3 by 2R. And if I write it down, what we have got is a very interesting idea that R cube is nothing but 2 by 3 whole cube. You can see that the value of R here comes out to be 2 by 3. Now this is very crucial because what they are asking in the question is nothing but the ratio of A is to B is to C. So if I put the value, this is A is to AR is to AR square. A will get cancelled out, to 1 is to R square. We can put the value of R and get the answer. So 1 is to 2 by 3 is to 4 by 9. So if I multiply by 9, this will become 9 is to 6 is to 4. This is the answer. So you can see that B option matches. Now let us look into this next problem type, that is type 12 problem based on logarithmic and exponential series. Now technically this is not in the syllabus, but the series are used in series expansion in limits, and these are also included in questions based on series. So first let me tell you what is a logarithmic series. A logarithmic series is nothing but log of 1 plus x to the base e can be written as nothing but x minus x square by 2 plus x cube by 3, so on and so forth till infinity. This is an infinite series and mod of x is smaller than 1. Another important series that we should know is e raised to the power x, that is nothing but 1 plus x square by 2 factorial, x cube by 3 factorial, so on and so forth till infinity. There are two sub cases here. If I put replace x by minus x, this will become 1 minus x plus x square by 2 factorial minus x cube by 3 factorial, so on and so forth. And if you add both of them, e raised to the power x divided by 2 would be equal to nothing but 1 plus x square by 2 factorial, x raised to the power 4 factorial, so on and so forth till infinity. And e raised to the power x minus e raised to the power x by 2 will be equal to nothing but x plus x cube by 3 factorial plus x raised to the power 5 by 5 factorial till infinity. Now see, this is the basic theory that we need to know in solving all such kind of questions. But more importantly, what will work out practically is if we can somehow not do this and use integration and solve the question. Like this was asked in 2024. In this question, I will not do it using the logarithmic series part. Lot of books and solutions have that logarithmic series used, but I will remove all of that, simplify in such a manner that you can do this without even knowing the logarithmic series. Now let us look into this question. So if you want to solve this question, first thing to observe is in the numerator, what is happening is if I take root 3 minus root 2 as nothing but t, then this series can be rewritten as, you can see that here what we have is t square, so on and so forth. And now with that, if I just include one more thing, and that is nothing but root 3. If I take this as t, then what is happening? The series can be rewritten as 1 plus. Now you can see that this would be nothing but t by 2. The next part will become nothing but t square. And if I square this, it will become, the 6 will remain. Then t raised to the power 3. Now if I cube it, you can see that the denominator will become 3 root 3. So this will become by 12, so on and so forth till infinity. This is the first and very important crucial part, so that it simplifies, those roots etc. get removed. Second part in such kind of question would be to split this. So now what we are doing is, very carefully, we are writing this term as t minus t by 2. The next one is nothing but t by 2 minus t by 3. The next one is nothing but square t cube by 3 minus t cube by 4, so on and so forth till infinity. This is very important. Why we are doing so? Because by doing this, I can rewrite this into two series. One is 1 plus t square by 2 plus t cube by 3 till infinity. At the other part can be written as nothing but, let us take a minus sign common. So I can write this next part as nothing but t by 2 plus t square by 3 plus t raised to the power 4, t raised to the power 3 by 4 till infinity. So you can see that now if I can find the sum of both of these series in isolation, we will be able to get an answer. This is what we need to figure out. So these two series I need to figure out. For doing that, I can see that if I just figure out the first one, I will be able to figure out the second one very easily. So if I just take this series 1 plus t square by 2 t cube by 3 till infinity and find the sum of this series. Now in order to do that, I indirectly do it using calculus. So I can consider a series that looks like this: 1 plus t square plus t cube up till infinity. You can see that this is infinite GP, can be written as 1 upon 1 minus t. And if I integrate both the sides, this will become t, this will become t square by 2, t cube by 3. So I have integrated both the sides. And then t raised to the power 4 by 4. And this will become minus of ln of 1 minus t common. This is what we are getting. You can see that we have got the sum of these part. This is very important because now this series can be rewritten as nothing but 1 minus ln of 1 minus t. This is what we are getting. Now this is very crucial and important to understand, because if I know this, then the second part, that is S2, that is given to me, can also be rewritten, because if I just multiply and divide by t, this will also become t square by 2, t cube by 3, so on till infinity, which can in turn be written as nothing but 1 by t. And now you can see that we have this part from here we can substitute. It is minus of ln 1 minus t mod minus t. We have got the sum of both the parts. We can substitute in the first series and get the answer. So you can see that I have circumvented the whole logarithmic part by doing integration and getting the answer. Now type 13 questions are based on the idea of arithmetic geometric progression. That would mean if I write a general term, it will have a general term of AP, that is a plus n minus 1 into d, and a multiplication of same with a term of GP, a r raised to the power n minus 1. If this happens, such kind of progression would be known as nothing but AGP. Now let us look into this series. You can see that this question is given to us. Now if I look into each of the terms, you can see that 1 by 4, 1 by 4 square, 1 by 4 cube, this is nothing but the GP part, and this 3 plus p, 3 plus 2p, 3 plus 3p, this is nothing but the arithmetic progression part. So this is beyond any doubt a AGP, though AGP are out of layers, but this question was anyway asked in the exam. Now if I want to solve this question, how am I going to do it? So you can see that if AGP is given to us, let us take the series as nothing but S. The technique is very simple. We will write the series 1 by 4 square 3 plus 2p, so on and so forth till infinity. Multiply the same with the common ratio. Common ratio in this case is nothing but 1 by 4. So this will become 3 by 4. Shift the series by 1 unit. So this becomes 3 plus p till infinity. And then subtract them. So it is very simple. In the second step, we have multiplied by common ratio. And then in the third step, we are subtracting them. If I subtract first and second, it becomes 3s by 4 on the left hand side, wherein this becomes 3. 3 by 4 will get cancelled out. This will become p by 4. This will become nothing but p by 4 square. Like this, it will go till infinity. Now you can clearly see that this is nothing but an infinite GP. I can apply the formula. So a upon 1 minus r. And if I simplify, you can see that this becomes 3 plus p by 3. This is what we have got. Now see, they have given the value of s as nothing but 8. So let us put this as 8. So 3 into 8 by 4 is nothing but 3 plus p by 3. This gets cancelled out. And from here, you can now get the value of p by 3. It will be equal to 6 minus 3, that becomes 3. So p comes out to be 9. So there are 3 simple steps. One, you write the series. You identify it as AGP. Second, you multiply the same thing with R. Once you have figured out that, subtract that, you will get a GP, find the sum of that GP and finally get the answer. If I move towards this 2024 question, it says that again you have been given a series Sx, 1 plus x, 2 times 1 plus x square. You can again see that this 1 plus x square, this is nothing but the GP term. And this 1, then 2, that is written, then 3, this is nothing but the AP term, so this is nothing but an AGP. If I want to solve this question and find the value of S and then ultimately the answer, I will have to follow the same steps. So in the first step, I have identified it as AGP. Let me write it down. This is 1 plus x. In place of x, I will write t to simplify my calculation. So this is t. This is 2t square. This is 3t cube. And we are going till 60t raised to the power 60. This we have written. T here is nothing but 1 plus x. We have done this to simplify things up. In the second step, we are going to multiply with this common ratio. The common ratio in this course, in this part is nothing but t. And then shift by one term. We will get t square plus 3t cube. And then this will become nothing but 59 t raised to the power 60, and last term you can see will become 60 t raised to the power 61. In the third step, we are going to subtract them, and if I do so, it is sx into 1 minus t. This comes out to be t plus t square plus t cube. You can see that it will go like this till t raised to the power 60, and then we have got just one term, 60 t raised to the power 61. Now if I want to find this value, I can apply nothing but a sum of GP here because these terms are in GP. So A into R raised to the power n, you can see that there are 60 terms, minus 1 by t minus 1. And then I have 60 t raised to the power 61. So now if I want to get the value of s from here in the fourth part, it comes out to be nothing but t into t raised to the power 60 minus 1 by t minus 1 whole square, but with a minus sign, and plus 60 t raised to the power 61 by t minus 1. Once I have got this, now I have got everything. All I need to do in the next part is substitute the value of t as nothing but 1 plus x. So this is minus of 1 plus x. If I put here 1 plus x, this will become x square. This is 1 plus x raised to the power 60 minus 1. And then what we have, 60 into 1 plus x raised to the power 61 divided by 1 plus x, so this will become x. Substitute the value of x as 60 and get the answer. Answer comes out to be 3660. The next type of question is based on summation notation. Now whenever you are using summation notation, there are few properties. First one is the property of distribution. So you can distribute summation over two terms. If you have x plus y, we can distribute over addition. We can also distribute over subtraction. So if you have these two terms also, we can distribute it. Third is the idea. If you have a constant inside, we can take this constant also outside. Second set of properties for summation is nothing but the summation of 1 n square, n cube and r raised to the power n. These four ideas. So if I take first summation of 1 from n is equal to 1 to n, this will be equal to n. Summation of n from n is equal to 1 to n, this will be n into n plus 1 by 2, that is nothing but sum of n natural numbers. Summation of n square similarly from n is equal to 1 to n is n into n plus 1 to n plus 1 by 6, and fourth is nothing but summation of n cube from n is equal to 1 to n. It is nothing but the answer of the first part only, second part only, but with a square sign. And the fifth one is nothing but summation of r raised to the power n from n is equal to 1 to n. You can see that this part will become nothing but a GP. So if you write it down, so whenever in doubt, you can write it down. If you write it down, it becomes a GP. You can apply the sum of GP to get the answer. Then last property is based on double summation. So if you have double summation involved, so where you have two things, let us say r and k. So r then k, like this is given to us. For solving double summation questions, what we will do is we will use this idea that if you have, what they are asking is if you have a plus b whole square, then a square plus b square plus 2ab will come. If I want to get the value of ab from here, it is nothing but a plus b whole square minus a square plus b square divided by 2. So we can use the similar logic and write this as nothing but summation of n whole square minus summation of n square divided by 2. So this is a very small shortcut that can be used to solve all such questions. If I look into this 2024 question, it talks about the concept of summation of series. See, whenever you want to apply this concept, there are steps. The first step is to write Tn. Once you have written Tn, you will apply summation of Tn. Apply the properties of summation and get the value of Sn. These are the three steps that we are going to follow. Now the problem in this question is we can't figure out the value of Tn because the way they have written, it is difficult to do so. So what I am doing, I am writing a new series. This is S dash, this looks like this, the same term but without the square part. I am doing this to figure out the value of Tn because only then I will be able to apply the summation. So what I have done is I have written this series up till Tn. Now what we will do in order to find Tn is we will shift the same series
And you can see that I have written the same series, but once we have shifted below this, there will be Tn minus 1, then you will have a Tn. Now this is also T dash n, this is not Tn. The relation between Tn and T dash n is Tn is nothing but square of T dash n. This is the relation. So once we have got this thing right, let us figure out the value of. Now if I subtract them, left hand side becomes 0, this is 1, this is 3, this will become 4, this will become 5. You can see that this becomes 6, and this goes on till n minus 1 terms. So this will go on till n minus 1 term. That you have minus T dash n. Now this term will take on the left hand side. And you can see that it is an n minus 1 term, but terms that are written are nothing but in arithmetic progression. So what we can do is we can apply the formula of sum of arithmetic progression. So n by 2 twice of a plus n minus 2 into d, that is nothing but 1. Now if I simplify this, let us see what do I get. It is 1 plus n minus 1 by 2, and this comes out to be nothing but 6. So this becomes n plus 4. Once we have got this, the value comes out to be 1 plus n square plus 3n minus 4 divided by 2. And if I further simplify, this comes out to be nothing but n square plus 3n minus 2 by 2. This is what I have got. Once we have got this value, then in the next step, we can square and figure out the final answer. So now, in the third part, if I want to get the value of nothing but Tn, it is nothing but square of T dash n. So this comes out to be n square plus 3n minus 2 by 2 whole square. This becomes n raised to the power 4 plus 9n square plus 4. This is what we can write. And then we can also write here 2ab. So that will become 6 times n cube. Further, what we have is nothing but 12n minus 12n and ultimately 4n square. We have this value. So once we have written this value, let us simplify and write the final answer divided by 4. So if I want to write my answer in the fourth step, let us write the value of Tn, because then we'll put a summation over Tn and get the value of Sn. You can see that if I write this value, what I have got? I have got summation of n raised to the power 4. And this Sn is given as nothing but alpha, so let us write alpha. Then what we have is nothing but, you have 6n cube. So plus 6 times summation of n cube. Then what I have is nothing but 4n square plus 9n square. That will become 13n square. So 13 times summation of n square. And finally what we have is minus 12 summation of n. And finally what we have got is nothing but a constant term 4, that is summation of 4. So you can see that now this divided by 4 is something that we have got. Now if I substitute the value, I get my answer. If I take 4 on the other side, it becomes 4 alpha. This is summation of n raised to the power 4. This is given as beta. I can also take it on the left hand side. You can see that we have generated 4 alpha minus beta, that is asked in the question. Now you can see that this is equal to 6 times summation of n cube plus 13 times summation of n square minus 12 times summation of n. And 4, if I sum it to 10 terms, it becomes 40. Now, all I need to do is apply the standard formulas of n cube and summation of n square and get the final answer. Now in this next 2024 question, we are going to follow exactly the same approach. But before doing this value, we will divide this into two sequences. There is this first sequence that is written in the numerator. 1 into 2 square, 2 into 3 square, till 100th term, 100 into 101 square. So in order to solve this, we will take the nth term, that is nothing but n into n plus 1 whole square. Now if you open this up, this will become n cube plus 2n square plus n. And if I want to sum up till n terms, that is summation of Tn, that will become summation of n cube plus 2 times summation of n square plus summation of n. If I substitute the value, this will become n into n plus 1 by 2 whole square, 2 times n into n plus 1, 2n plus 1 by 6, and finally n into n plus 1 by 2. Now here all I need to do is substitute the value of 100 to get the value of S100. That is what we need to find. So if I put 100, this becomes 100 square into 101 square by 4. This becomes 2 into 100 into 101 into 201 divided by 6, and finally 100 into 101 by 2. This is what we have got. Similarly, in the second part, I will find the value of h dash. You can see that again we have got is 100 term. But this series, what we have is 1 square into 2 plus 2 square into 3 up till 100 terms. So let us write the general term. So t dash n, if you write, it is nothing but n square into n plus 1. If I simplify, this becomes n cube plus n square, and summation of t n dash will give us nothing but the value of s n dash. It is summation of n cube plus summation of n square. I can substitute the value, becomes n into n plus 1 by 2 whole square plus n into n plus 1, 2n plus 1 by 6. So you can see that we have got the value. All we will do is put the value and then simplify and get the answer. So now what we need to do finally, now we could have done it without simplification also, we want to divide both of these series. I think it would be easier if I substitute it in the form of n and ultimately put the value of n as 100 and get the final answer. So let us substitute it. So we can see that n into n plus 1 by 2 will get cancelled out. And what will be left in the numerator is n into n plus 1 by 2. This part will become 2 times 2n plus 1. And then we have 1. Divide by, you can see that again here n into n plus 1 by 2, 1 will remain, and 2n plus 1 by 3 will remain. Now you can substitute the value of n as 100 and get the answer. The final answer of this question comes out to be option A. Now next problem type, that is type 15, is based on the concept known as method of difference. Now in such kind of question, the steps are like this. First we'll write the Tn or the nth term. We'll split it. Then we are going to rewrite the series. After doing this, what will happen is alternate terms will get cancelled out. And ultimately we will be able to get an answer. So you can clearly see that this process is split into 1, 2, 3, 4 and 5 steps. If you apply these 5 steps in all such questions, you are going to get the answer. Now let us start with a simple question that was asked in 2024. Question says that you have been given 2 different series. Now if I take the series 1, what we have got is 1 upon root 1 plus root 2. Root 2 plus root 3. Now this question in this format has earlier already been asked in JEE. So this is not a new question. So what we are going to do is we are just going to rationalize this. So this becomes root 2 minus 1. This becomes 2 minus 1. This becomes root 3 minus root 2. This becomes 3 minus 2. And so on and so forth till 100 minus root 99. And then this becomes 100 minus 99. So you can see that the denominator of all the terms become 1. It is root 3 plus 1, root 3 minus root 2. We have got this series. And now we will see that alternate terms will get cancelled out. So this root 2 got cancelled out. Similarly root 3. And ultimately root 99 will get cancelled out. So what you have got is root of 100 minus 1. That comes out to be nothing but 9. So once you have got this, the first series is done. We have got the value of m. M comes out to be 9. Now let us move on to the second. Now you see that the same 4 steps that I have told about you earlier. We will write the Tn. It is nothing but 1 upon n into n plus 1. The splitting technique is very simple when the terms are in arithmetic progression. You will take the last one. first one and subtract them. So we can, in the second part, split it up by subtracting n plus 1 n from n plus 1. And if I do it so, you can see that this becomes 1 upon n minus 1 upon n plus 1. After doing this, we are going to rewrite the series. So this was my first step. Let us write this as 1. This is my second step. Now in the third part, I am going to rewrite the series. So I will put the value of n starting from 1 to 99. So sum of series 2 will become nothing but 1 minus 1 by 2 plus 1 by 2 minus 1 by 3, and it will go up till 1 by 99 by 100. You can see that now alternate terms got cancelled out. So what we are left with ultimately in this case also in the fourth step we'll get the answer. S2 comes out to be nothing but 1 minus 1 by 100, and that is nothing but 99 by 100. Now this value is considered as nothing but n. Now question says that mn n. Now you can see that after this you have got the point mn n. They are asking which line it satisfies. So if you choose option B, you will have to check it for all the options, but I am just checking for B option. So left hand side becomes 11 into m, that is nothing but 9, minus 100 into 99 by 100. You can see that this comes out to be 0. So B option becomes the correct choice. Now this is repetition of the similar kind of concept. Again we'll start with the same 4 steps. We'll write the Tn first. You can see that what we have is nothing but 1 plus n minus 1 into d. Then what we have is 1 plus nd. If I want to split it up in the second part, I am going to take 1 plus nd on this side, subtract 1 plus n minus 1 into d format. And if you do it so, you can see that what you are going to get is nothing but d. And that you will have to write it in the denominator. If you subtract it, you will get it. This is 1 plus n minus 1 into d. And this is 1 plus nd. If you split it down, it will become, the first term is 1 plus nd by d, that will keep outside, into 1 plus nd into 1 plus n minus 1 into d, and second part will become 1 plus n minus 1 into d by 1 plus n minus 1 into d into 1 plus nd. And if I simplify, 1 by d will simplify itself to 1 plus n minus 1 into d minus 1 upon 1 plus nd. Once you have got this, there is a step 3 that talks about rewriting the series. So if I rewrite the series, first term comes out to be 1 by d times. This will become 1 minus 1 by 1 plus d. Second will become 1 by d times 1 upon 1 plus d minus 1 plus 2d. And now you can see that this will go up till nothing but, if I put go till 10 terms. So upon 1 plus 9d minus 1 upon 1 plus 10d. So we have done till this term. Now we can see that alternate terms will get cancelled out. So these terms will get cancelled out. This will be the pattern. And in the fourth step, we will be able to write the answer. The answer comes out to be nothing but 1 by d times 1 minus 1 upon 1 plus 90. Now in the next part, they have given the value of s is nothing but 5. So once you have got this as 5, I can write this as 1 by d is nothing but 1 plus 10d minus 1. I have taken LCM by 1 plus 10d. You can see that this will get cancelled out. D will also get cancelled out. So 1 plus 10d is nothing but equal to 2. So 10d will be equal to 1. So if I want to find the value of 50d, it is going to be 5. You can see that A option matches. Now again, this kind of question is again based on the similar logic. So we will write the Tn. So it is going to become 1 upon 1 minus 3n square plus n raised to the power 4. Now this denominator splitting is like very typical, and this you should know. N raised to the power 4, if I just take the denominator, minus 2n square plus 1 minus n square can be written. Now this part will become nothing but a perfect square. So n square minus 1 whole square minus n square. Now we can apply the formula of a square minus b square. So this becomes n square minus n into n square minus 1 plus n. So you can see that I have split it into two parts. So this term that looks like this will eventually look like this: n square minus 1 plus n and n square minus 1 minus n. Once we have got this, now let us rewrite the term. There was an n in the numerator as well, yes. So in the second part, if I want to write this up, you can see that now this Tn can be split. How? Because this numerator we are going to multiply and divide by 2. This becomes 2n by n square minus 1 plus n and n square minus 1 minus n. So this 2n in the numerator, now here we can write it as nothing but n square minus 1 plus n minus n square minus 1 minus n. If I subtract them, 2n will remain, and this is crucial because now again we are going to split it into two parts. Now this numerator, if I split it into two parts, first will become n square minus 1 minus n, the second one will become n square minus 1 plus n, if I split it into two parts. Now in the third part, we are going to rewrite the series. So you have got nothing but 1 by 2. I need to go till 10 terms. So again I am going to write it down. So if I put 1, it becomes 1 minus 1 minus 1. So it is going to become minus 1. If I put 1 on the other side, it is going to become 1. The second term will become 1 by 2 times. If I put 2, it becomes nothing but 4 minus 3, it becomes 1. And if I put 2 in the other part, it becomes 4 plus 2, 6. 6 minus 1 becomes 5. You see that this whole idea will follow till the 10th term. Now whatever I write here is unimportant. The other part would be important because if I put here 10, this is going to become 100 minus 1 plus 10. Now based on the pattern that we have discovered, all of these terms will get cancelled out. And in the fourth step, you can see that only these two terms will remain. There is a minus 1 here and then minus 1 upon 100, 1/10. So this will become 109. I can simplify and get my final answer. So it comes out to be nothing but minus 110 by 109. So I can simplify and this comes out to be B option, that is nothing but minus 55 by 109. Now this 2024 question is an extremely interesting question because this involves what we did earlier plus something more. So if you just write this series that is given to us, this series will become nothing but 1 by 1 into 2, and then we can write this as nothing but 1 upon 4 into 3, and then 1 by 2024 into 2023. Now we can split it up by writing 2 minus 1 by 1 into 2 plus 4 minus 3 by 3 into 4, and this we can do till the last term. So 2024 minus 2023 divide by 2024 into 2023. Once I do so, I will be able to split it up as 1 by 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, and ultimately 1 by 2023 minus 2024. Once I have done that, I can again rewrite the series as 1. All the odd sounding terms I will take on one side till 2023, and all the odd sounding terms I can take it on the other side. So what we have is 1 by 2 plus 1 by 4 till 1 by 2024. See, now we want 2024 in the answer, so this 2024 I will keep separately and I will play with the remaining terms only. So it is 2023, this part is fine. Now from here I am taking this 2024 term away, so it is 1 by 4. It will go till 2022, and this one term I am keeping it separately, 2024. What is the benefit of doing so? See, now this term that I have written, I can add and subtract one more time. So if I add this 1 by 2, 1 by 4, you can see that I have included all of these in the first term. And now this will become 2 times 1 by 2, 1 by 4 till 1 by 2022. And then we are still left with this minus 1 by 2024. Now we can see that this will get cancelled out. And now first 1011 terms will get cancelled out, and what we are left with is nothing but 1012 plus 1 upon 1013 till you can see that 2023 minus 12024. We have got the second part of the series. Now if I subtract it from the first part, let us see what do we get. The second part, if you subtract, we have 1 upon alpha plus 1 plus alpha plus 2 till 1 upon alpha plus 1012, and what we are subtracting is nothing but 1 upon 1012 minus 1 upon 1013, and it will go till minus 1 upon 2023 plus 1 upon 2024. This is what we are getting. You can see that this will become equal to 1 upon 2024 only if these terms get cancelled out, and that will get cancelled out if the value of alpha becomes equal to 1011. Now let us look into this last question of today's discussion. So in this, they have given the value of T1, they have given the value of TR, they have also given you the value of Sn. They are asking for what value of n will this be valid. So now for doing this question, what we are going to do is, first we are going to find the value of T2 from here. So if I put 2, this becomes 3T1 plus 6. So if you put the value of T1, it comes out to be 6 plus 6. Similarly, I can put 3. So this becomes 3T2 plus 6 square. And this will become 3 square into 6 plus 3 into 6. This was 6 square, sorry. And then nothing but 6 raised to the power 3. So once you have this, you have observed a pattern that what is happening. If I write it for Tn, the last term will be nothing but 6 raised to the power n. And before that, you will have 3 into 6 raised to the power n minus 1. And it will go till the first term where you have 3 raised to the power n minus 1 into 6. So like this you have a pattern, and you can see that this is nothing but a GP. So you can find the sum. There are n terms here. So if you start, the first term is 3n minus 1 into 6. The common ratio will become 2. So 2 raised to the power n minus 1 by 2n. If I simplify this, this would become nothing but 3 raised to the power n by 3 into 6. This will become 2 raised to the power n minus 1. If I multiply, this becomes 2 into 6 raised to the power n minus 2 into 3 raised to the power n. This is what we have got. Now this is Tn. From Tn, now we can apply summation, find the value of Sn. So in the next part, we are going to find the value of Sn by putting summation of Tn. N is equal to 1 to n. So you can see that this will become 2 times summation of 6 raised to the power n minus 2 into summation of 3 raised to the power n. Now this is not very difficult because what you have got is 6 squared till 6 raised to the power n. This is 2 into 3 plus 3 squared till 3 raised to the power n. Once you have done like this, this comes out to be nothing but 2 into a into r raised to the power n minus 1 by r minus 1. This will become 2 into 3 into 3 raised to the power n minus 1 by 3 minus 1. And this is what we have got. Once you have got this, now we have got the value of Sn from here. We can simplify. This comes out to be 12 by 5, 6n minus 1. And the second comes out to be nothing but 6 by 2 into 3 raised to the power n minus 1. So this will become 3. Now once you have got the value of Sn from here, the third part also talks about the value of Sn. We can compare both of these. So now we can compare this 1 by 5 n square minus 12n plus 39 and then 4 into 6 raised to the power n minus 5 into 3 raised to the power n plus 1. Now once you compare both of these terms, you will be able to get the value of n. N comes out to be nothing but 6.
If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time. And based on that, in step 2, we write a customized planner just for you to help you optimize your marks in JEE Mains exam based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited, no or good preparation and all have been able to score their marks to a large extent. Ashish, using this program, was able to improve his fortunes by lot, starting from 95 percentile in JEE Mains attempt 2 to getting selected for mechanical in IIT Madras. Ditya, over a period of time, was able to crack into JEE Advanced using this program. If you think that this seems interesting to you, click on the link below in the description, fill the required details and somebody from my team will get in touch with you.